developing scientists. So I guess Meditations on First Philosophy would be one of his very important works, as it's, I mean, as well as the graphing system. I mean, that's used. Without that, we may, you know, I'm sure that's been used to create all kinds of things, technology, computers, who knows? I don't know, but I'm just saying without that, we probably wouldn't be where we are today talking over the internet and all these like things. So, I mean, between those two issues, I believe to be the most important at the moment, yeah.
All right, just one more. In terms of the domains of science, where do you think, I mean, where do you think? It doesn't have to be one, it could be more than one, but just tell us.
Yeah, like I said at the end there, I tried to sneak it in, the body of knowledge, because he's written so much and so much publications are available from this man. The body of knowledge would be a major one, as well as the way of thinking, because a lot of his thinking was fundamental to developing methodology that's used today. So I don't know if that makes sense. His way of thinking.
Yes.
All right.
Makes sense to me.
Alrighty.
Okay. All right. Actually, thank you. Does anyone else have anything you have a comment, or you have a question or anything you want to put forward at this point?
Yes. What did you say actually about graphs? Did he develop graphs?
The Cartesian system. You know, we talk about the Cartesian plane, the X and Y system that we use in terms of drawing our graphs, and yeah. So he developed that. And that actually, so when you look at his name, so the Cartesian part, right, that is actually, so when you talk about the Cartesian system, that's actually named in honor of him, because he did quite a bit of work on math, and that's one of the things that he came up with.
Okay, all right. Because of science, I'm thinking graphs like GRAFT.
Okay, no, not that. All right, okay. Let's proceed then. All right, let's see who is next. All right, Galileo, that's Samuel. Samuel?
Thank you.
Okay.
Please, can I share my screen?
Sure. Hold on, let me stop sharing mine. Go ahead.
Can you see my screen?
Not yet.
Can you see that?
Not me. Did you click share screen, Samuel?
Yes, I did.
All right, it's beginning now. Hang on.
To the right.
Yeah,
Below.
I can see it now. We can see it now, Samuel.
Okay. So, who was Galileo Galilei? He was born on February 15, 1564. He was an astronomer, astrologer, Italian physicist, and also a philosopher who was associated with scientific revolution. He was also called and referred to as father of modern astronomy, father of modern physics, and also father of science. Galileo died on January 8, 1642. Galileo Galilei was born in Pisa, Italy, as I said before, 1564. His father's name is Vincenzo Galileo, who was a famous musician. Galileo had 5 brothers and sisters, but some of historians said he has 6 siblings. He was only 8 years old when his father moved to Florence. He was educated at Calamandos Monastery at Vallombrosa, and at the age of 17, he studied medicine at the University of Pisa. 2 years later, he preferred to study mathematics with Ostilio Ricci. And these are the various inventions made by Galileo Galilei. We have the Galilean thermometer, military compass, telescope, and the compound microscope. So about the telescope, he was not the first that invented telescope, but because of his scientifically thinking, he had some piece to the telescope. And what he did was he had some lenses which made him to magnify what the telescope can see. So that was like a new discovery, and some of the notions he went against it because of what he could see in addition to his own telescope. He also invented the pendulum, which has helped now to make the pendulum clock. And also in his observation and experiment about pendulum, he noticed the factor, which is a period, how it can be affected by the mass of the pendulum and also the length of the thread. So he made all the discovery from his observation about changing the length of the pendulum, the mass of the pendulum. So in that now, it has helped now in the inventory of the pendulum clock. And also, he was able to discover the 4 largest moons of Jupiter, I guess, through his telescope. And that's why the 4 largest moons of Jupiter are called the Galilean moons. And you can see the picture on the screen. He also made some observations about the moon. He proved that the heavenly bodies were imperfect, although the Greek denied that. And also, he was able to draw the drawing of the moon, which you can see on the screen. And he also did some experiments using an inclined plane. He noticed that objects, even regardless of their mass, they get to the bottom of the inclined plane together. And he also noticed that even when they get to the bottom, they can still move. So he said, even with no force acting, some objects are still moving. And that was also what helped in the law of motion, which Isaac Newton brought forward later. Yes, he also made an observation which disproves some of the ancient ideas. And one is 2 objects with different weight can fall down at the same speed. And we have what we call the Galileo scientific method, which I noticed was also related to the claim by falsification. In Galileo scientific method, we have one, you have to make and record precise observation. you have to seek possible explanation for observed facts. 3, you have to test the theory with experiments. And 4, you have to draw conclusion only when all the experimental evidence gathered support a particular theory, which I notice is very close to what Popper claim in his falsification claim. And also Galileo Galilei is one of the most influential famous scientists in human history, having contributed to a wide range of fields and establishing the mathematical and experimental foundation of modern physics and astronomy. Yes, in his final years, Galileo passed away on January 8, 1642, at the age of 77. And in fact, his body and remains were awarded a great tomb when he died. And he was buried in Florence, Italy. Yes, from what I've read and seen so far, mm, Galileo contributed to the three domains of science. And what I noticed about his contribution to science as a body of knowledge was his explanation of how two objects with different weight fall at the same time. Because this has helped a lot of scientists nowadays to know that what he did then has able to explain vacuum, and that regardless of the weight, that two objects can still get to the ground at the same time. Also, I noticed about he also contributed to the science as a way of investigation from his method of investigation, which is called Galileo's scientific method. And also, I noticed he also contributed to science as a way of thinking because he opposed to the geocentric theory and supported the heliocentric theory, which brought him into a lot of trouble with the Catholic in those days. He was arrested, he was put in house arrest, and later died. But what in his opposition to the geocentric that is helping a lot of scientists nowadays that the sun is the center of the planet and not the earth. Yes, that is it.
All right,
Yeah.
Samuel. Thank you. All right. Before I make any comments or ask you any questions, I will open the floor to the other members of the class if you want to make any comments or if you have any questions for Samuel on Galileo, etc. No. All right, Samuel. All right.
Yes.
Okay. One little thing before I even ask any question, just in case I forget, I don't want to forget it. You showed us the Galileo scientific method, and you said that it resembles falsificationism.
Claims, yes.
Um, I'm not sure I agree with you. I can't.
No, because when I was trying to compare, I noticed some of the falsification theory, the steps that you have to take through to conclude in your experiment is similar to that of Galileo scientific method.
Yeah,
I noticed about the observation, the theory, before you can
yeah.
make your conclusion.
But one of the things, well, I guess the first point that I saw that you had under his method was that it starts out with observations, and
Yes,
that is the key point in induction, that science begins with observations, right? So and he has Galileo's view is similar. So I think from that standpoint, I would say that his way of thinking and operating is far closer to the inductive method or the inductive approach than the falsification approach.
Okay. Because what I was thinking of, most time observation comes with thinking. And like you want to solve a problem, so you start thinking about it. And I notice falsification starts with thinking about a problem before you can start experimenting on it.
Right. So for in falsification, you recognize that you have a problem, and then you
Mm-hmm.
basically develop a sort of hypothesis about what may be causing it, etc. And you go about trying to falsify it
Mm-hmm.
through the investigation. But
Mm-hmm.
what I noticed, unless I saw incorrectly, with what you shared with us about Galileo's method, it started with observation, not observation in terms of seeing a problem, but remember how the inductivists talk about observations. That science starts with observations because you are a blank slate, right? Your mind basically, and when you observe, facts come to you. Statements of facts actually just imprint themselves in your mind, and that's what I got from what you had, from what
O-
Galileo said. So I thought,
Okay.
I mean, we could go on about this, but I thought it more closely resembled um, what we know to be the inductive method.
Okay.
All right, but
Yeah.
what was I going to ask you now?
Yes.
Oops. All right, I don't quite remember. It has eluded me, my question. All right, but for the most part, I mean, in terms of what you have shared, basically you have answered what I have asked you to. And oh yeah, so easy question. Which aspect of science, not the domains, no, I mean which fields, right? Whether it's chemistry, etc. Which
Mm-hmm.
which part of science would you say that Galileo has made the greatest contribution in your estimation?
Yeah, physics. Because simple pendulum, law of motion, all
Mm-hmm.
that, and it has really done a lot in law of motion. Because from what I read, even oh, all what you have to say has a lot to do with how how we can interpret what is happening around us about the law of nature. So most
Mm-hmm.
of what it has to do have to do with their surrounding, and most of them are explained as a theory or as a law in physics.
Yeah. Um, I would have liked if you had told us the story. I think it's an interesting story. It doesn't take away anything. The story of how he was able to prove um, that hypothesis that he had about the two objects falling at the same time, and how the view that dominated prior to that was that there was no way, and how he went to the top of the mountain and he carried out
Uh,
experiments and whatever.
yes,
Yeah.
he did that in two ways. One, he did that in a vacuum and
Mm-hmm.
also use an inclined plane. Because
Mm-hmm.
he noticed in a vacuum, because there is no air in it, that the there's no gravitational pull that will affect the two objects. So the two objects can get to the ground at the same time. And
Mm-hmm.
also when he tried that with inclined plane, he noticed that wow, these two objects they have the same, they have different weights, but they get to the ground at the same time. So he used the vacuum and also inclined plane to prove that,
Yeah.
which opposed the idea before then.
Right. And just to bring everybody in, I mean, one of the things that Galileo, I mean, in doing that experiment, he did a very public experiment. Based on my reading of it, he actually went to a mountain, um, and carried out the experiment in full view of, not just the scientists, but in full view basically of ordinary persons, because there were so many persons who thought that, all right, surely, I mean, even though probably you just ask different persons, if I have this small thing and this big thing, which one do you think is going to fall faster? Everybody's going to be like, duh, everybody knows that the heavier one is going to come to the ground faster. But which was a kind of common sense view. Everybody thought that was naturally so, but he actually carried it out very many times and was able to show that that wasn't true. And but the thing about it is that in spite of the the fact that he did this experiment very publicly and people were able to see the results, not everybody actually accepted it immediately. And that is one of the things that we were talking about, that even though we may have scientific evidence and it is clear to people, people are not always so willing to just change their views about, you know, what has dominated for a very long time. And that could be considered to be a sort of impediment to science in a way, and keeping us back. But thank you, Samuel. Good job.
Commis.
All right, and we'll continue. So let's see who is next. All right, let me just tell you. All right, so the next one is Lamarck, and Vanessa is going to share with us. All right, so Vanessa, take us away.
I'm having some technical difficulties. Could you come back to me, please?
All right, so we just have one left. So it's Tracy. Can you go?
Yeah, I could have guessed.
Can you go before Vanessa?
Yeah, I'm fine. I can go now.
Okay, all right. Please go ahead.
Okay, I'm doing Henry Cavendish. He was a natural philosopher, an experimental and theoretical chemist and physicist. So he was obviously a very busy man. He was notoriously shy, but he was distinguished for great accuracy and precision in his researches. Some of his research and findings included the composition of atmospheric air. He discovered hydrogen, but it was not named until Lavoisier repeated his experiments. Another great achievement of his was he measured the density of hydrogen. His figure was only half of what it should be, but apparently the way he got there was pretty good. This is a biologist speaking now. He investigated the products of fermentation. He researched the properties of gases, the synthesis of water. He researched the law governing electrical attraction and repulsion. He developed a mechanical theory of heat, and he also made calculations of the density and hence the mass of the Earth. His experiment to measure the density of the Earth has come to be known as the Cavendish experiment. I really tried to understand it, but I think Sandra is a physicist, if I'm not wrong, and maybe she could explain that at the end, because it was beyond me.
It's okay. You don't have to explain the intricacies.
Yeah, I didn't even get them, so we're good. He was born October 10th, 1731 in Nice, France. He died February 24th, 1810, when he was 79 years old. His family tree spanned 8 centuries and was closely connected to many aristocratic families of Great Britain. His father was Lord Charles Cavendish, son of the 3rd Duke of Devonshire. His mother was Lady Anne Grey, daughter of Henry Grey, the 1st Duke of Kent. But unfortunately, his mother died in 1733, just before his 2nd birthday. With all this nobility, obviously equates wealth. So I think that was pretty common with scientists of those days. They came from a wealthy background. His wealthy background allowed him to attend Hackney Academy, a private school near London, when he was 11. And then when he was 18, he attended the University of Cambridge, but left 3 years later without a degree. I mentioned earlier that he was noted for accuracy and precision, but he was also noted for being a shy and odd person. It's been suggested that he had either Asperger's syndrome or being, let me see if I can get this word, anthropophobic, which basically he was terrified of women, and he only communicated with his female servants by notes. So he was so reserved that even when he attended science meetings, and he was so reserved that attending science meetings and similar activities were his only social activities. But even at these events, he didn't really engage with anyone. And it was said that if another scientist tried to engage him in conversation, he would squeak a reply and then go sit in another corner. To me, I thought another example of his oddness is when he was doing experiments on electricity. He measured the strength of a current by shocking himself and estimating the magnitude of pain. You may think that this demonstrates how he was thinking like a scientist, similar to those cartoons that you see, where when a non-scientist touches something and gets a shock, they don't touch them again. But with the scientist, they keep touching it to see if he'll get a shock every time. Sorry, ladies, I know I said hey, he, but that was deliberate because a female scientist wouldn't do this. They would have the man getting the shock while they worked at a method of measuring his reaction. Don't you agree? I'm sure there's 3 that don't agree, but we won't go there. Just trying to lighten it up a bit, guys. I don't really mean that. Well, not really. Well, maybe. Anyway, his first introduction to science was from his father. His father had been a scientist as well. When Henry was 27, in 1958, his father took him to meetings of the Royal Society and also to dinners of the Royal Society Club. In 1760, he was elected to both of these groups. From these beginnings, Henry went on to dedicate his life to science through research and participation in science organizations. He was active in the Council of the Royal Society of London, headed a committee to review the Royal Society's meteorological instruments, and to help assess the instruments of the Royal Greenwich Observatory. Other committees on which he served included the Committee of Papers, which chose the papers for publication in the Philosophical Transaction. He was elected a trustee to the British Museum, to which he devoted a good deal of time and effort. Cavendish became a manager of the Royal Institution of Great Britain in 1800, shortly after it was established. Do you remember I said he was a busy man? So you can see that that was true. Unfortunately, because of his asocial and secretive behavior, Cavendish often avoided publishing his work. He published no books, despite all that I discussed that he did, and only published 20 papers. Much of his findings were not even told to his fellow scientists. Almost 100 years after his death, James Clerk Maxwell looked through his Cavendish's manuscripts and found things which anticipated the work of scientists who followed him, i.e. others were credited for things that he had actually discovered but not shared, such as Richter's law of reciprocal proportions, Ohm's law, Dalton's law of partial pressures, principles of electrical conductivity, including Coulomb's law, and the Charles law of gases. My conclusion, it was unfortunate that he did not share more of his findings, but his work on gases that he did share and the calculations for the mass of the Earth were of great value. He also contributed to his fellow scientists by improving equipment and techniques, e.g., he perfected the collection of gases over water. Thank you.
Thanks, Tracy. That was nice. That was interesting. All right. We could talk about personality a little bit, because I don't know if you realize that when we read some of the stories about scientists, we find them a little bit eccentric. That's a nice word, a nice way of saying it. Perhaps though that is all a part of the curiosity and the creativity. Sometimes people who are very curious, very creative are not very well understood, and people tend to think that they're a little strange. So in the case of Cavendish though, I knew of his extreme shyness and fear of women. And I mean, that limited him, as you mentioned. That seemed to have limited him a lot. I mean, he was terribly shy to the extent that he wouldn't share much of his work. And actually, I think there's a story about how he communicated with his housekeeper. He would avoid her like entirely, you know. So she was supposed to have kept out of his way, you know. Being a woman, he really didn't want to make any sort of contact with her. He was extremely afraid of women. But sometimes the point I'm making though is that sometimes the characteristics that we have in terms of personality characteristics can sometimes limit us in one way, but in another way they perhaps are what really makes us different. And as scientists, you know, those sort of creative and curious and different kind of persons that we see. So I suppose you have to take the full package together. You can't have one without the other. But I don't know. What do you guys think? Oh, yes, you're being invited to say something if you wish. No? Oh, since nobody else is talking as you're Tracy, I just wanted to make the point. I guess it would be a fair assumption, I mean, depending on whose story you read, to think that a lot of the scientists had money during those times. Lavoisier, for example, his family he came from money family. Cavendish also came out of a family with money and links to royalty. But you had some poor guys. I mean, we looked at them. Like John Dalton, for example, was very poor. There's this other guy. He's a chemist. I don't remember his name just now. He also came from an extremely poor family, and he actually came by his discovery. He did some work on electrochemistry. He actually came by his discovery by working as an apprentice, and it was through the apprenticeship. I mean, not an apprentice as in learning the trade, but just a helper in the shop. And it was just through that he got interested in science and realized that he had a really good knack for it. And, you know, people helped him along and he was able to improve himself. Yeah, so they didn't all have money, but some of them did, which that was good because that helped to move the science along a little bit in terms of what you could do in terms of equipment and more studies, etc.
Miss, are you talking about Michael Faraday?
Faraday, yes. I couldn't remember his name. Thank you. Thanks, Samuel. Yeah, Faraday. Yes.
Welcome.
All right. All right. We are now ready for Vanessa. Are you ready for us now?
I haven't resolved my technical issue, which is the fact that I have to have the computer almost upside down in order for you to be able to hear me. And my screen is motion sensitive, so it keeps flicking upside down.
Oh.
It flips the image upside down. So I don't know, it's not such a big problem for me, but I don't know if when I share my screen that it's going to be upside down for you guys too.
All right, well, go ahead and share it and we'll tell you what we see.
Okay, can you see that?
Yeah, and it's the right side up.
Oh, good. It's me looking at it upside down then.
Okay.
Hang on, I'm swing over my screen here. Okay. So Jean-Baptiste Lamarck was born in 1744 on the 1st of August. He died in 1829 at the age of 85, which at that time he lived a good long life.
Mm-hmm.
Oh, it's not happy with me changing slides. Okay. So his full name, and I apologize for my accent, was Jean-Baptiste Pierre-Antoine de Monet, Chevalier de la Marque. He was born in a commune of the Somme, where the famous battle happened much later, in France. He was the last of 11 children to impoverished French nobility, and in those days the youngest son was generally expected to go into the priesthood, so his family sent him to the Jesuit college. He had other ideas, and the year that his father died, he left the college and joined the French army to go fight in Germany. He was promoted to officer age 17. His daughter actually told this story of how his entire regiment was decimated. There were only 14 of them left, and the older guys decided to elect him an officer so that he could order with the withdrawal from the battlefield. So he accepted the promotion and then ordered them to stay right where they were until reinforcements arrived. So when the general arrived and saw what he'd done, he was immediately promoted to officer permanently. When he was 24, he was playing a game where you pick people up by their heads and suffered a neck injury, and surgery to treat it actually made it worse. So he was given a medical discharge. When he left the army, didn't really know what he wanted to do, but his older brother was studying medicine, so he went and joined him. And while he was at university, he was working at a bank to support himself. As he was studying medicine, he became progressively more interested in the natural sciences, specifically in botany. But he also branched out into physics, meteorology, astronomy, and chemistry. He spent 10 years studying under the renowned botanist, someone whose name I can't pronounce. And at 34, he published his first work. He published a lot of books in his 85 years. Flora Française was a 3-volume work about the plants of France, and was actually notable for being the first, having the first dichotomous key to try and identify plants. In 1779, he was elected to the prestigious French Academy of Sciences and spent the next 2 years touring Europe looking for new botanical specimens. He returned to France to take up a post at the Royal Herbarium at the Jardin du Roi, which, because of the French Revolution, changed its name to distance itself from the king, to Jardin des Plantes. And in 1793, he helped to reorganize it into the French National History Museum. A year later, all 12 of the officers who participated in the reorganization were appointed professors. There were, however, only 2 botany professorships, and there were 2 scientists who were significantly more famous than he was. So he got placed in charge of insects and worms, which he didn't know a lot about. But he decided he was going to learn everything he could about them, and he was actually the one who coined the term invertebrates. And as he observed the differences between these species, that was where he started to formulate his ideas about the relationships between animals and how one animal could mutate into something different. And in 1809, he published his theory of transmutation. It was not particularly well received. In fact, very little of what he wrote was well received. He was the first scientist to propose a gradualistic theory of evolution as opposed to the commonly accepted saltationist theory where things just spontaneously appeared. He believed that all of creation was in a constant state of advancement and that ultimately it would reach perfection, but he defined perfection as human. So each generation was an improvement over the last, and he actually observed this progression in the fossil record. And as I said, he postulated that mankind was the perfect specimen that all other organisms were trying to become. However, with all the stuff that he's done, what people remember about him is his theory of the inheritance of acquired characteristics. So he proposed that anything that happened to an individual in their lifespan was passed on to the next generation. And that was the means by which organisms altered over generations. He believed it was a function of sexual reproduction, so the alteration must have happened to both parents in order for it to be passed on, and that these changes were very small and probably not observable in short periods of time, so you'd actually have to have a few generations before you noticed a significant difference. He also proposed the theory of disuse, which was that any organ that was not used would eventually disappear, which is why snakes do not have legs. His example. They used to, but they didn't use them, so they vanished. So his most quoted examples are the giraffe, which started with a short neck and short legs and continually stretching to reach leaves higher and higher in the tree. That particular giraffe's neck started to stretch, and not much, but enough, and it mated with another giraffe that's neck had also stretched, and the offspring had a naturally longer neck, which then stretched, and so on and so forth until you get the giraffe that we see today. Proposed the same theory for the legs and webbed feet of wading birds, that as they tried to wade deeper into water, they stretched their legs longer and longer to stay on the surface, and with each successive generation, they had longer legs. So obviously he got the details wrong, but it was an ingenious explanation for what he could see around him. And his work served as the foundation for other scientists, most notably Darwin. And Darwin actually also believed in the inheritance of acquired characteristics. He did not rule that out. So was he really wrong? And most people are going to say yes. But the study of epigenetics, which is the study of how proteins affect DNA itself, is actually showing that you can inherit acquired characteristics. And there's a whole load of technical jumble that I'm not going to go into. But instead of a change in the DNA, it's a change in the way that the DNA is handled by the cell. So he believed that organisms started very, very simple, single cells, and they became progressively more complex. And that this followed the influence of natural laws. It wasn't just random. So, as I said, a lot of his published work was not well accepted, and he was ridiculed quite significantly. One of his colleagues, Cuvier, at the Academy, actually in his, I've forgotten the word, obituary, completely ridiculed all of his theories, which was not the done thing at the time. But even though people didn't believe him, people ridiculed him, people accused him of heresy, he was not going to give up. He persisted with what he was going to do, and this made him a lot of enemies and is the reason that his career did not progress any further than it did. So I'm not going to read all of these. You can read them for yourselves. He published a lot. I have 3 slides of this. As I said, the book on French flora, the 3-volume one, contained the first dichotomous key for identifying species based on contrasting characteristics. So, with plants, is it a monocot or is it a dicot? And so on. As I said, he was the first person to not only use the term invertebrates, but also to divide them up. So he split up echinoderms, arachnids, crustaceans, and annelids. The arachnids had always been labeled as insects, and he was the first person to separate them. He also did studies in hydrogeology, and His work was the basis of tectonic plate theory. His observations that things tend to move in the same direction, and that the eastern coast of a landmass tends to have certain characteristics versus the western coast. And in 1802, he specifically published his theory of evolution. He expanded on that in 1809 and continued publishing until 1822. Now, in 1818, he actually went blind. So his work after that, he was assisted by his daughters. So he found time to write papers on physics, meteorology, and several annual compilations of weather data, which was a lot more complicated than it is now because we just go onto a website now.
Yeah.
Charles Darwin actually talks about him in Origin of Species and says he did the eminent service of arousing attention to the probability of all changes in the organic as well as the inorganic world being a result of law and not of miraculous interposition. So Lamarck actually officially married 3 times, possibly 4. There are rumors of a 4th wife, but there is no records to back this up. He had 6 children. They didn't have a lot of luck. 1 was deaf, 1 was clinically insane, 1 became an engineer. 3 daughters, 1 died. The 2 who survived were the ones who helped him publish his later works, and they were left with nothing when he died. He died so poor that his family couldn't afford to bury him. They had to beg for money to rent a grave for 5 years, and this was apparently the system at the time in France. After 5 years, the body's dug up and just thrown into the Paris catacombs. So there's no actual grave for Lamarck. But they do have a memorial up for him somewhere in Paris, and his name is in a large number of species. And there's some further reading.
Thanks, Vanessa. I guess if we're sharing that story in our class, we want to leave out the part about him dying of pauper, because then probably won't inspire anybody to go into science. We just leave that out conveniently.
It's too late for the rest of us. We're already.
Yeah, yeah, it's too late for us, but for the students, you know, hoodwink them a little bit.
Yeah, he died very wealthy.
Yeah. All right, thank you very much. Thank you very much. Thanks everybody for sharing the stories. I hope that just going through you know, researching the lives of these scientists, that the experience itself was interesting and you really learned a lot. Oh, somebody's who's having difficulty hearing. Samuel? Samuel?
Yes, it's better now.
Oh, it's better now. Okay, great. Yeah. So I was just I'm just tying up this part and saying that, you know, there are so many other stories. I mean, there's like huge number of scientists that, you know, we can look at and that apply to the different things that we're teaching as we're going through our chemistry or physical, bio or agri or environmental science. That's the different aspects of our subject matter. We can, you know, you can pick a story from here or something. It doesn't necessarily have to be in the form of a story. There are various ways that we can just incorporate the works of these scientists and perhaps use it. Even when we were talking about, you know, Cavendish and how shy he was, and those who lost their parents when they were young. You know, probably you may have a student in your class who has a similar situation and is thinking that, boy, you know, they can't really do very much because they don't have the support system or so. In some ways, we can use these stories just to motivate them, to let them know that, hey, not, you know, people before you went through really difficult times and they made it, so you can make it too, you know. So we can use it in that way. But next week we'll look a little bit more on that, about how we can use what we know about the history of science, how we can incorporate some of these things into our class. We have begun to talk about it. We've actually been doing that. And even looking at the movie that we had, the video that we had on Tuesday of Aristotle, you know, we began to talk about, you know, how we could use something like that. And I want you to be thinking about, very actively thinking about things that you can do, activities that we could do, how we could modify these things and just incorporate them as a part of class, not as something else in terms of adding time on to what you already have to do, but how we can fit seamlessly into a lesson and so that you have a really just a great lesson, right? All right, so that is that part. Unless anybody does anybody want to make a comment before we move on? Do you have anything you want to add? Anything, doesn't matter what it is.
Good. Hello, it's Tracy.
Yes, Tracy. Hello.
I'm finding it difficult to hear you.
Oh, you're not hearing me?
Not very clearly. I guess, yeah, not clearly.
Was that from the beginning or just now?
I didn't get that question.
I was asking if that is a recent development or that was from the beginning. Vanessa, could you thanks? Yes, Tracy. I was asking if you're not being able to hear me very well, if that's a recent development or that was how it was from the beginning.
Pretty much from the beginning, but it seems like it's getting more difficult.
All right. Okay. I'm going to. All right. Let's take 5 minutes then, and let me ask the technicians to see if they can do anything about it. All right. So let's just take 5 minutes. Back in 5 minutes. All right. So everybody just take a short breather.
Okay.
Okay. How is it now? Yeah. But you have been able to feedback. Okay.
That is always from the microphone. But when we can go to microphone, but that is there is something like this.
Hi, folks. Hello again. Welcome back.
That sounds great.
Oh, okay, that's good. Okay. All right. So we're going to proceed. So I'm going
Actually, Professor, the volume is a little low.
the volume is a little low. All right.
I was hearing you better before, but now to me it seems a bit low.
All right. How is it?
Pardon me?
How is that? No, I turned it up, so I was asking how is that?
It's quiet.
Oh, all right.
I have my earphones up to maximum capacity.
Okay, hold on. How is that?
Yes, that's better. Thank you.
Okay, all right. All right. Okay, so are we all ready to proceed?
Yes.
Okay, great. All right, so I'm going to share something that I have here. Slide it down.
Is the assignment due, you said on Monday?
Yeah. Yes, and I'm giving, well, I've given you extra time basically, but yeah. Well, yes. Brief answer to your question is yes.
All right, I had a question regarding the assignment. Assignment 2. The CXC syllabus, science syllabus. You want us to look at the planning and designing from any syllabus. Is there a specific source that you have, or just anything that we can find online?
What do you mean a specific source? I mean, all
for various CXC science syllabi.
No, anyone will do.
Okay.
Chem, biophysics, yeah. They all pretty much the write-up on the planning and design.
Alrighty.
No, I'm saying that for if you look at your chemistry, bio, or physics syllabus, the write-up about planning and designing is probably going to be the same across the board.
I'm sorry, it's a little quiet. Can you say that again?
I said, if you take a look at, there is noise in your background. I don't know if that is affecting your hearing. But I was saying that if you look at the chemistry syllabus, they pretty much are the same in terms of what they say about planning and designing. So it wouldn't really matter which one you look at, which one you read from.
Okay, I'm just going to Google CXC. I'm not very familiar with it, but I'll find something that you're looking for. Hopefully it's what you're looking for, planning and designing.
Do you have a copy of the syllabus?
CXC, no.
All right, because I can send you a copy because I've sent it. If you I wish you had said that before, because then I mean I could have sent it before, so you could have started looking at it. All right.
So you're going to send a copy then?
I can send you a copy. I have sent it to you.
Yes.
If you had asked me, I would have. I said.
Yes, please.
All right, no problem.
No problem. I have a whole weekend to work on it, right? So it's not a big deal.
Okay, all right.
Also,
but thank you for your assistance.
Sure, no problem. I just sent it to everybody.
Okay, thanks.
All right.
Thank you.
No problem. All right. All right, we'll go on. If you have any other questions, feel free to voice them. Actually, I want to spend a little bit of time, probably towards the end, just fleshing out the 1 week that we have left, how we're going to approach it.
Excuse me, Professor Ashley?
Yes,
from Bermuda.
Yes,
is it possible that you can turn your mic up a little bit more? I see a few of my comrades are also struggling to tune into your voice. It's a little quiet.
Okay, all right. Let's go for that. Okay, I want to say. Does that help? Is that better? No change?
No, it's the same way. I don't know how all of a sudden it's not too clear and it's a lot of static.
All right, okay. Hang on. How is it now? Hello?
Yes, that's better. Thank you.
I think it's better.
Okay, okay. Ava?
Yes, I could hear you clearly.
Yes, I responded yes.
Okay, great. All right. So we proceed with this. Yeah, we'll continue then. All right. Okay. So, continuing, I want you to do this activity. I don't want you to think about it. I want you to go straight ahead and do it. So 2 minutes. All right. Seems like you guys working on those masterpieces.
I hope you're using masterpiece very.
Okay. All right. Can you share? I'd like to, if we can see them. We can try. So can we see what you have?
Okay, I guess I'll start first.
Okay, Sandra.
I picked William Beaumont because for some reason he just sticks very clearly in my head.
Oh, I just wanted you to just sketch, not a particular person, just a sketch of a scientist.
So, can you explain a bit better for me?
Right. No, I was saying I didn't want you to pick up any particular person, just the perception that you have when you think scientist. Just sketch what you think of.
Oh, okay. Well, forgive me, my daughter is giving me a little yeah, she needs attention. For a scientist, number one, it helps a lot if you have some money or some way of funding your experiments. And scientists tend to have some sort of curiosity about something they have noticed. There may be an observation, or it may be a problem that came up, or it may just be plain serendipity. But they all seem to have this curiosity and this wish to find out why. And then they go about it in a methodical process where they try to, well, some of them just did it sort of from a philosophy point of view, but then others tried to do a sort of establish empirical data, and tried it under different conditions.
Sandra, sorry.
Yeah.
I think it's probably me. All right. So not a character sketch. I actually wanted you to draw it. Just draw a scientist. That's what I meant. All right. So it's my fault. My bad. What I wanted you, when I said a sketch, just like a little drawing of your perception of a scientist. So when somebody says scientist, what's a picture that comes into your head, into your mind? That's what I'm going for.
Oh, okay. I get you now.
You get me. Did everybody get that? I can give you one more minute.
Yes, I get it. Do you describe what we draw, but are you able to see that? Can you see it?
I can't see anything now. Is it possible for you?
Okay, well, I can describe it, I guess.
All right. Okay. All right. Okay. Go ahead then, Eva. All right. Sandra, you can just work on yours, and then we'll come back. All right.
Okay. I hope I have words to describe. My scientist is a male. He has a very, very long nose.
Okay.
His hair is all scanty, all about the place, not properly combed, not properly groomed. And I have some little ideas going on in his head, serendipity, and other questions. He's asking other questions. So his head is full of ideas. His pants is way up, like Urkel. His hands he has a belt. He has also, his hands are filled. He has trying to hold a book, a test tube, a microscope. His hands are filled. He has on no proper shoes. He's like a slipper. He's all over the place, a catapult. And he's just there. He's just like he's lost, don't know where to start and what to do. Because he has so many ideas, you don't know where to begin. So that's my idea of a scientist, my little sketch.
Okay, thanks, Eva. I see you showing yours, so just go ahead.
Yeah, when I saw the little assignment, I just thought of images of like cartoon scientists like Frankenstein. But then I also thought you wanted us to draw a popular scientist, so I was attempting to draw this guy with the crazy hair.
Okay.
My representation of what's his name? Albert Einstein. I was trying to do the crazy hair, but that's it.
Okay. All right.
Yeah.
Okay, next person. This is interesting.
Samuel?
Yes, Samuel, please go ahead.
Yes, my drawing is very simple. I
Uh-huh.
see scientists wearing a glasses.
Glasses?
Yes, reading and experimenting, and in a room alone.
And what?
In a room alone, in a room.
Oh, in a room alone. Okay.
Yes. So reading, experimenting, wear pair of glasses, and in a room alone.
Okay.
Yes.
Is your scientist, that's a male?
Yes.
Okay. I'm making notes. All right. That's why I'm asking you. All right. Thanks, Samuel. Next.
Linton.
Yeah, Linton.
Okay, I have a little diagram. I don't know if people could see it. I don't think you could see it clearly.
It's all white. It's just
all
light,
white.
too much light. Yeah.
Right. It's a sketch where I'm looking at a man with white hair, long white hair that's curled.
Long white hair.
Yeah, with a lot of beard under his chin, with his glasses, always with a white lab coat with 2 big pockets.
Hold on. Hold on. You're going a little fast. Okay. A lab coat.
Yeah, always wearing a lab coat with like 2 big pockets. And along with a black pants.
Okay.
Normally with a black shoe.
Okay. Very like that.
In his hands, he like normally holding up to get the meniscus of a glass jar in his hand.
So he has some scientific apparatus in his hand.
In his hands, yes.
All right, let me see if I've captured everything. All right, so you say it's a male with long white hair, long white curly hair. That was it. And has a long beard.
Right.
And he's wearing a white lab coat with huge pockets on the front of it, and black pants and black shoes and apparatus in hand.
Right.
Okay. All right. So I've captured it. All right. Next person.
This is Tracy.
Yes, Tracy. Please go ahead.
I put a female sitting in a boat with wearing a bathing suit, no shoes, hats.
Sorry.
It's a marine biologist. That's what I am.
No, I'm not. Okay. All right. Boat, bathing suit.
Gotta have your hat and shades.
Hat and shades.
No shoes.
No shoes.
And lots of fish under the boat.
Okay, lots of fish on the boat. All right, this is very interesting. Yes, Tracy, thank you. Next one. I won't get everybody. JC, you ready?
Yeah, I guess so.
All right, go ahead.
Can everybody see it if I just hold it up?
Yeah, okay, all right. So, come back, back into, right.
There.
Okay, so glasses.
Yeah, male with glasses, curly hair, and he's like mixing chemicals that are like bubbling, wearing a white lab coat.
Right.
That's it, basically.
So he's in the lab.
Yeah.
Okay.
Yeah.
All right. Thanks, Jason. Let me see. Vanessa. Vanessa, can you hear me?
Yes. Can you hear me?
Yes.
My absolutely fantastically drawn stick figure
Yes.
is a female with her hair tied back in a ponytail, wearing safety specs and a lab coat with pockets filled with pens.
Okay.
The lab I used to work in, because pens always went missing, people would fill their pockets with them until the pockets ripped.
Okay.
There was always a fight for the Sharpies. And she's holding a flask with liquid in it.
Okay.
And grinning somewhat manically.
Okay. Okay. All right, thanks, Vanessa. 1, 2, 3, 4, 5, 6, 7. All right. Back to you, Sandra.
Okay, I'm not sure if you can see my crazy scientist.
Yeah, I can see some of it. All right, let's see.
Right. I have my scientist over a table with some with test tube and beakers, etc., in front of him. And all around it, and he's got a little cat in a cage beside him.
Okay.
And also a computer on a desk as well. And around him in little clouds, I've got at the top of his head ideas. And then I've also got ethical issues beside the cat and animal rights.
Okay.
And I've got data, technology, criticism, going around him to sort of show all the different things that are happening around him while he's doing his experiments. Yeah, he himself, well, it's a male. He himself, the hair is a little crazy, a little out of whack. But he looks very focused, sort of has a little frown on his forehead there.
Okay.
Yeah, and that's it.
All right. Thank you very much. This has been a really interesting exercise. All right. So if I summarize what we have, all right. So out of 8, we have 6 male scientists. We have we have about 6 crazy hairs, and we have 2 that have kind of painted the scientist as, you know, somebody whose head is always full of ideas, thinking about various things. We have a little bit of craziness going on in our general description that, you know, not all together here. We have that. We also have the focus that we just got from Sandra. 7 of the 8 descriptions I think that you have given me are about 6. The scientist is wearing glasses. In most of them, wearing lab coats with pockets on it. Long beards. All right. And generally mixing chemicals in the lab. All right. So, what's different then? I have 2 females that came from Tracy and Vanessa. 2 females. One is typical of the other descriptions: lab glasses, lab coats, etc. in the lab, grinning a little crazily as if she's kind of maddish. And right. And then I have one female who is in a bathing suit, in a boat, with hat and shades, no shoes, and lots of fish under the boat. And I think this is all very interesting. But one of the this is an exercise that often has been given to children, little children, like when people are doing research on scientists who want to find out what students' views are about how they perceive a scientist. They generally give them an idea, an assignment to sketch a scientist, and then to talk about their sketch, right? And I thought that we would do it because I just wanted to see what we would do. And surprisingly, this, for the most part, we have come away with a typical description that is presented of a scientist. A scientist is typically presented as somebody who is kind of half crazy. Everybody don't think they kind of have it all together. It's generally a male, and that's generally a white male. I should have asked you guys, but that would have kind of been a giveaway. So it's generally a Caucasian male with freaky hair, right, and lab glasses and in a lab coat. So those all the typical things have come out, right? What has also come out is that there is also some movement towards the idea that, yeah, we also have female scientists, and they don't always have to be working in a lab, and they use technology, and yeah, so we're getting there. And I did this because we were going to look at women in science. So we're going to look at women, all right, and hopefully, you know, next when we begin to think about scientists, when we think about scientists from here on out, we don't just think male, but we also think female for all of us. All right. Okay, so let's go on to the next one. So as I said, we're looking at women in science. There are loads of women in science. I mean, when I started looking at the research, when I started researching and just look at women in science and the contribution that they have made, there are lots and lots of women in science. You know, it's just interesting to study their stories. We don't have the time to even touch the tip of the iceberg. We just want to pick out one or two and look at them. So even some of the ones that are going to, whose names are going to come up here, we won't look at them, but just so you're familiar with the names, you can go away and look at the stories. All right, so we've done this already. All right, we've shared the drawing, so yeah. All right, so some female scientists that you may or may not have heard about. There's Rachel Carson, Rosalind Franklin, Barbara McClintock, and Briska Marie Curie, Paula Tennant, and loads more. All right. So I'm going to pick out some now that I want us to look at. So I'm going to ask you to, from your readings, I want you to pick up the Rosalind Franklin story. I'm going to ask you to read it, and then we're just going to share a little bit. All right. So the Rosalind Franklin, I'll probably give you like 5 minutes or so on that. Well, probably a little bit more than 5. All right, so up to the Rosalind Franklin story.
Can you repeat yourself? I didn't clearly get it.
Oh, I'm sorry, Linton. We're reading about Rosalind Franklin. So you have a file that says that. You found it?
Okay, so we just read it.
Yeah, you're reading it. We're going to talk about it. So you want to pick out the major points.
Okay, fine.
All right. But one of the things that we could do, one of the ways we could do this, perhaps to save on time, is to actually ask persons to read different parts of it. So I don't know what you think of that idea. So we could read it out loud and just have different people reading different parts, and we just pick out the ideas as we go along, because we have a couple of things we want to look at. Right. So
yeah, that sounds fine.
Okay, so yeah, so somebody can start then. I mean, everybody will have to read a part because we have a couple of stories. So somebody can go ahead.
Rosalind Franklin. Synopsis. Born in 1920 in London, England, Rosalind Franklin earned a PhD in physical chemistry from Cambridge University. She learned crystallography and X-ray diffraction techniques that she applied to DNA fibers. One of her photographs provided key insights into DNA structure. Other scientists used it as a basis for the DNA model and took credit for the discovery. Franklin died of ovarian cancer in 1958 at age 37. Early years. British chemist Franklin was born into an affluent and influential Jewish family on July 25, 1920, in Nottingham, London, England. She displayed exceptional intelligence from early childhood, knowing from the age of 15 that she wanted to be a scientist. She received her education at several schools, including North London Collegiate School, where she excelled in science, among other things. Rosalind Franklin enrolled at Newnham College in Cambridge in 1938 and studied chemistry. In 1941, she was awarded second-class honors in her finals, which at the time was accepted as a bachelor's degree in the qualifications for employment. She went on to work as an assistant research officer at the British British Coal Utilization
Go ahead.
Research Association, where she studied the porosity of coal. Work that was the basis of her 1945 PhD thesis, The Physical Chemistry of Solid Organic Colloids, with special reference to coal. In the fall of 1946, Franklin was appointed at the Laboratoire Central des Services Chimiques de Esfat in Paris, where she worked with crystallographer Jacques Meringue. He taught her X-ray diffraction, which would largely play into her discovery of the secret of life. The structure of DNA. In addition, Franklin pioneered the use of X-rays to create images of crystallized solids in analyzing complex, unorganized matters, not just single crystals. Scientific discoveries and credit controversy. In January 1951, Franklin began working as a research associate at the King's College in London, the biophysics unit, where Dr. Jean Randall used her expertise in X-ray diffraction techniques on DNA fibers, mostly on proteins and lipids in solution. Studying DNA structures with X-ray diffraction, Franklin and her student, Mr. Gosling, made an amazing discovery. They took pictures of DNA and discovered that there were two forms of it, and dry A form and a wet B form. One of the X-ray diffraction pictures of the B form of DNA, known as photograph 51, became famous as critical evidence in identifying the structure of DNA. The photo was acquired through 100 hours of X-ray exposure from a machine Franklin herself had refined. I wonder if that's why she had died of ovarian cancer, but anyway.
Exactly, yeah.
Sorry. Back to reading. John Desmond Bernal, one of the United Kingdom's most well-known and controversial scientists and pioneer in X-ray crystallography, spoke highly of Franklin around the time of her death in 1958. As a scientist, Miss Franklin was distinguished by extreme clarity and perfection in everything she undertook, he said. Her photographs were among the most beautiful X-ray photographs of any substance ever taken. Their excellence was the fruit of extreme care in preparation and mounting of the specimens, as well as in the taking of the photographs. Just excuse me. Despite her cautious and diligent work ethic, Franklin had a personality conflict with colleague Wilkins, one that would end up costing her greatly. In January 1953, Wilkins changed the course of DNA history by disclosing without Franklin's permission or knowledge her photo 51 to competing scientist James Watson, who was working on his own DNA model with Francis Crick at Cambridge.
And,
Upon seeking the...
sorry, Vanessa. Oh no, that's Ashley, right?
Yeah, it's Ashley.
Sorry, Ashley. And all of us would probably have heard of Watson and Crick, right? The two names being put forward here. Watson and Crick are like famous guys.
Can't say I have.
All right. Okay. All right. We'll talk about it afterwards. Carry on then. Carry on.
Upon seeing the photograph, Watson said, "My jaw fell open at the pulse. My jaw fell open and my pulse began to race," according to author Brenda Maddox, who in 2002 wrote a book about Franklin titled Rosalind Franklin, the Dark Lady of DNA. The two scientists did in fact use what they saw in photo 51 as the basis for their famous model of DNA, which they published on March 7th, 1953, and for which they received a Nobel Prize in 1962. Crick and Watson were also able to take most of the credit for the finding when publishing their model in Nature magazine in April 1953. They included a footnote acknowledging that they were stimulated by a general knowledge of Franklin and Wilkins' unpublished contribution, when in fact much of their work was rooted in Franklin's photo and findings. Randall and the Cambridge laboratory director came to an agreement, and both Wilkins and Franklin's articles were published second and third in the same issue of Nature. Still, it appeared that their articles were merely supporting Crick's and Watson's. According to Maddox, Franklin didn't know that these men based their Nature article on her research, and she didn't complain either, likely as a result of her upbringing. Franklin didn't do anything that would invite criticism. That was bred into her. Maddox was quoted as saying in October 2002, Franklin left King's College in 1953, March, and relocated to Beck College, where she studied the structure of the tobacco moasis virus and the structure of RNA. Because Randall let Franklin leave on the condition that she would not work on DNA, she turned her attention back to the studies of coal. In 5 years, Franklin published 17 papers on viruses, and her group laid the foundations for structural virology, illness and death. In the fall of 1956, Franklin discovered she had ovarian cancer. She continued working throughout the following 2 years, despite having 3 operations and experimental chemo. She experienced a 10-month remission and worked up until several weeks before her death on April 16, 1958, at the age of 35. 37, sorry.
Okay, thank you, Ashley. All right, let me just get your feedback. What are your thoughts? You've read the story. What are your thoughts?
Interesting story, not surprising. I wish there was a picture of her so I could see.
Oh, I do have a picture. Hold on.
Is it on the link there?
No, it's on my screen. So I have to share it with you.
Okay.
Roslyn. That's her.
Ah.
Yeah.
Anyway, anything specific that you're looking to pick my brain about?
No, and I'm not just looking to pick your brain. I'm actually talking to everyone. I want the ideas to begin to flow. We're going to look at a few other women, and we're going to have a discussion. So I want the discussion to come kind of like on the back end. But what are there any things that strike you? Anybody else yet? Any issues you see coming out? Yes, Samuel.
Yeah, Samuel Dominica.
Yes.
I'm just surprised that in 20th century that someone can still be denied of his or her work. To me, I thought every scientist, when they do finding out something, other scientists will always get to know about it. So I got the impression as if everything she did, nobody knew about it. But I thought that shouldn't be happening in 20th century.
When you say people didn't know, what you mean?
The DNA, the research she did, like I thought in 20th century, a lot of scientists should have known about it. So instead of Watson and Crick going to present, other scientists should have known about our findings.
Oh, okay. So all right. So let's get into the issue then, because this is one of my issues. Hold on, Ashley. All right. Because one of the things, it isn't explicitly stated in the article, but it is stated. One of the issues that arises out of Rosalind Franklin's story in particular is this business of how you can have, what should we call it? We could call it corruption of a sort, for want of a better word. I'll come up with a better word in a little while. But essentially what happened to Rosalind Franklin, as you may notice, is that she actually, her finding, Watson and Crick are the guys who are known in biology as the persons who elucidated the structure of DNA, right? And DNA, we know, is at the heart of so many things, right? So that's really, really important. Now, how Watson and Crick were able, so they were working on DNA. Rosalind Franklin was also doing work on DNA. And as you read in the article, without Franklin's photograph, they would not have been able to write that paper and be able to come to the structure that they did. But instead of giving her the credit for it, they actually, so they stole the picture, we can call it that. They took the picture without her permission or without her knowing, so that's stealing. So they basically, so they stole her intellectual property, they stole her work, and then used it to publish a paper from which they got all the acclaim. And they, in fact, went on to win a Nobel Prize. So the Nobel Prize was awarded to Watson and Crick. Rosalind Franklin's name was not mentioned in that. So that's one thing. So I'm just putting that out there.
There's actually more to that story.
Yeah.
She was named as a candidate for the Nobel Prize, but the committee did not want to give it to a woman, and they postponed and postponed and postponed, knowing that she was sick. And as soon as she died, they actually started considering the application, because you can't award the Nobel Prize posthumously.
Yes. And another thing I think is that, well, one of the reasons that have been given, I don't think initially they had considered her among the candidates, but there was a lot of furor that was created because people were saying, you know, this lady, based on what she has done, you know, she really should have been considered. So perhaps it was afterwards that they started thinking about her as possibly awarding her along with the others for the Nobel Prize. But another argument that often is brought forward is the fact they say, I think it is, I don't remember, I think it is 3 persons that can share, maximum, that can share, can be named for a Nobel Prize, right? I'm not sure exactly what the politics were at the time, why, but she did not get on well with Watson and Crick. That much was evident. she didn't have a good relationship with them because they thought that she thought that she was all that, you know, and she was bright and she was female, and they felt that, you know, at that point in time in our history, to be a female and to be bright and to assert yourself, those things were not considered, you know, to be the norm, and was they weren't taken very well. And so there was a lot of tension between her and the other and the guys, the men. So yeah, so that's one thing. All right, so we'll bear that in mind, and we'll go on to another story. So can we now look at Barbara's story, Barbara McClintock? And somebody can go ahead and begin. This one is not as long. Oh, sorry, you weren't hearing me. I've been talking to myself. I said we're going to go on to the Barbara McClintock story, and I'm asking somebody to go to read this.
Okay, Barbara McClintock. Barbara McClintock made a great name as the most distinguished cytogeneticist in the field of science. Her breakthrough in the 1940s and 50s of mobile genetic elements, or jumping genes, won her the Nobel Prize for Physiology or Medicine in 1983. Among her other honors are the National Medal of Science by Richard Nixon in 1971, the Albert Lasker Award for Basic Medical Research, the Wolf Prize in Medicine, and the Thomas Hunt Morgan Medal by the Genetics Society of America, all in 1981, and the Louisa Gross Horwitz Prize from Columbia University in 1982. Her early life, education, and career achievements. Barbara McClintock was born on June 16, 1902, in Hartford, Connecticut. She was the third child of Sarah Handy McClintock and Thomas Henry McClintock, a physician. After completing her high school education in New York City, she enrolled at Cornell University in 1919, and from this institution received the Bachelor of Science degree in 1923, the Master of Arts in 1925, and the PhD in 1927. When McClintock began her career, scientists were just becoming aware of the relationship between heredity and the events they could actually examine in cells under the microscope. She served as a graduate assistant in the Department of Botany for 3 years, from 1924 to 1927, and in 1927, following completion of her graduate studies, was employed as an instructor, a post she held until 1931. She was awarded a National Research Council Fellowship in 1931 and spent 2 years as a fellow at the California Institute of Technology. After receiving the Guggenheim Fellowship in 1933, she spent a year abroad at Freiburg. She returned to the States and to the Department of Plant Breeding at Cornell the following year. McClintock left Cornell in 1936 to take the position of an assistant professorship in the Department of Botany at the University of Missouri. In 1941, she became a part of the Carnegie Institution of Washington and became a happy and fruitful association which continued for the rest of her life. In 1950, Dr. McClintock first reported in a scientific journal that genetic information could transpose from one chromosome to another, Many scientists during that time assumed that this unconventional view of genes was unusual to the corn plant and was not universally applicable to all organisms. They were of the view that genes generally were held in place in the chromosome like a necklace of beads. The importance of her research was not realized until the 1960s when Francois Jacob and Jacques Monod discovered controlling elements in bacteria similar to those McClintock found in corn, and in 1983 McClintock received the Nobel Prize in Physiology or Medicine for her discovery of mobile genetic elements. Her work has been of high value assisting in the understanding of human disease. Jumping genes help explain how bacteria are able to build up resistance to an antibiotic, and there is some indication that jumping genes are involved in the alteration of normal cells to cancerous cells. Her death. McClintock died in Huntington, New York on September 2nd, 1992.
Okay. Thanks, Jason. All right, any comments here before we move along? Yeah. All right, so that's one Nobel Prize winner done. All right, let's go to one that I think most persons know. Marie Curie. All right. Who wants to start us on Curie? We can have two persons reading this, but it's a little bit longer. I'll adjust a little.
Okay, I'll start off.
Okay, Ava, thanks. Go ahead.
Just a sec. Yeah, that. Okay. Marie Curie Maria, how am I going to pronounce that word, was born in Warsaw on November 7th, 1867, the daughter of a secondary school teacher. She received a general education in the local schools and some scientific training from her father. She became involved in a students' revolutionary organization and found it prudent to leave Warsaw. Then in the part of Poland dominated by Russia. For Krakow, which at that time was under Austrian rule. In 1891, she went to Paris to continue her studies at the Sorbonne, where she attained licentiateship. I don't know, something with license.
It's like a degree. Yeah, it's like a license, a degree.
In physics and the mathematical sciences. She met Pierre Curie, professor in the School of Physics, in 1894, and in the following year they were married. Love story. She succeeded her husband as head of the physics laboratory at the Sorbonne. She gained her doctorate of science degree in 1903. And following the tragic death of Pierre in 1906, she took his place as professor of general physics in the Faculty of Sciences. The first time a woman had held that position, Curie. She was appointed director of the Curie Laboratory in the Radium Institute of the University of Paris, founded in 1914. Her early researches, together with her husband, were often performed under difficult conditions. Laboratory arrangements were poor, and both had to undertake much teaching to earn a livelihood. The discovery of the radioactivity by Henry Becquerel in 1896 inspired Curie in their brilliant researches and analysis which led to the isolation of polonium,
Polonium.
named after the country of Marie's birth, and radium. Madame Curie developed methods for the separation of radium from radioactive residues in sufficient quantities to allow for its characterization and the careful study of its properties, therapeutic properties in particular. Madame Curie, throughout her life, actively promoted the use of radium to alleviate suffering, and during World War I, assisted by her daughter, Irene, she personally devoted herself to this remedial work. She retained her enthusiasm for science throughout her life and did much to establish a radioactivity lab in her native city. In 1929, President Hoover of the United States presented her with a gift of $50,000, donated by American Friends of Science, to purchase radium for use in the laboratory in Warsaw. Madame Curie, quiet, dignified, and unassuming, was held in high esteem and admiration by scientists throughout the world. She was a member of the Council of Physics, Solvay, from 1911 until her death, and since 1922, she had been a member of the Committee of Intellectual Cooperation of the League of Nations. Her work is recorded in numerous papers in scientific journals, and she is the author of, I think that's Research in Radioactive Substances,
Right.
1904, something with elements, isotopes, and the classic traits of radioactivity. I hope my translation is good.
I think the trait is wrong, but that's all right.
Okay. The importance of Madame Curie's work is reflected in numerous awards bestowed on her. She received many honorary science, medicine, and law degrees, and honorary memberships of learned societies throughout the world. Together with her husband, she was awarded half of the Nobel Prize for Physics in 1903 for their studies in the spontaneous radiation discovered by Becquerel, who was awarded the other half of the prize. In 1911, she received a second Nobel Prize, this time for chemistry, in recognition of her work in radioactivity. She also received, jointly with her husband, the Davy Medal of the Royal Society in 1903. And in 1921, President Harding of the United States, on behalf of the women of America, presented her with 1 gram of radium in recognition of her service to science.
Yes.
That's it?
Yeah, and she died. Yeah, she died on July 4th.
She died in France after a short illness, July 4th, America's birthday, 1934.
Yes.
Yeah.
Thank you very much. Yeah. All right, folks. So we have 3 stories. As I said, there are many, many, many more. But I have to leave those for you to look up, to research about. But some of the things that that come out of the stories, well, perhaps we'd have to explore some of the others for you to get an understanding. So there are issues of gender inequality is a big issue when you read stories, and notice that we're talking about 19-something, right? So in fact, as recent as 1992. But we're going to read a paper and you're going to look at what is happening now. But we'll read that in a little while. So there are issues of gender inequality or gender equality. There are ethical issues that arise as well. There are issues related to people dying from their work. So for example, as Ashley was pointing out, when we look at the story of Rosalind Franklin and how she died, she was very young when she died. She died at 37. And she found out like 2 years before that she had cancer, ovarian cancer. And it is very, very likely based on the type of work that she was doing, because she was in X-ray diffraction. So you know, you're working with all these kind of radiation, because X-ray is a form of radiation. People don't tend to think of it as being, you know, that dangerous. But I mean, if you're exposed to any form of radiation over time, this is something that actually builds up in your system. And so, I mean, I think we could kind of begin to think that her work, the nature of her work, actually kind of led to her death, her early death, and her death, the type of death from cancer.
Very ironic.
Yes, Emma.
I think that's very ironic.
Yeah, go ahead.
I'm thinking at that time, were people aware of the dangers of X-ray radiation, or
not as much as we are now? Not as much as we are now, certainly not. And another one, well, worse than that is Marie Curie's work, because they totally worked on very radioactive substances. So the polonium and the radium that we spoke of, and polonium and radium, for those of us who don't have a chemistry background, polonium and radium are two of the elements that appear on the periodic table, right? And they isolated polonium and radium, and they were working with pitch blend, right? So that was their ore, basically. So they were extracting the polonium and the radium from the ore. So they were working with an ore that was very, very radioactive. And the place where they were working was like a little workshop. It wasn't like a lab thing. And in terms of protecting themselves from the radioactive material at that point in time, I don't think they knew anything about you know, the effects of radioactivity on a person. So these are highly radioactive material, worse than the X-rays, much worse. And in fact, Marie Curie, it's not said here, but she actually died from what is called pernicious anemia, which is a form of cancer, right? Like cancer in the blood. So, and that is not surprising actually, but she lived a long time, because she was like 60-something when she died. So compared to Rosalind, she lived a long time, even though the kind of material that she was handling was far more radioactive than the sort that Rosalind was handling. But in a sense, when you think about it, you could kind of like say, you know, these people kind of like sacrificed their lives for science, you know, without even knowing that was exactly what they were doing. The other thing that I want to note, so a big kudos here for the women, is that not very many persons in the history of the Nobel Prize have received. In fact, I think it's only 2 persons who have received 2 Nobel Prizes in different fields. Because Marie Curie, she received the Nobel Prize, which they shared with Henry Becquerel, in physics, or was that medicine? It might have been in physics. So she received it in one field, and then she also received a Nobel Prize in chemistry. So she received 2 Nobel Prizes within a short space of time, one in 1903 and then in 1911. All right, so we know she's very, very talented. Her daughter, she in fact had a daughter, Irene Curie, who also won a Nobel Prize. So it's a family of very accomplished persons, we could say, right? So her younger daughter went on to win a Nobel Prize as well. And for me, Marie Curie is probably like one of the most inspirational women. So if you're going to talk to girls in particular about getting involved in science, her story is really a great inspiration. Of course, as I said, you know, some of these stories really speak of a lot of poverty, and you begin to get some insight, because one of the things that sometimes we think about scientists, we think that, well, they have all the money and they're living, you know, all this posh life and the whole works. But when you begin to read their stories, you realize that they were under some really, really harsh conditions, some of them. So, for example, in the case of Marie Curie, I mean, they just didn't have resources much of the time. So we begin to really understand, you know, that it's not all glittery and glitzy. There actually is quite a bit of hardship that, you know, accompanies their lives. All right, but I've talked a bit. So does anybody else wish to talk some more?
I had a question.
Yeah.
How did they use radium to alleviate suffering, like during World War One?
I think it was they had some. I'm not sure it was actually the radium itself, based on something that I read. I think they used it as a sort of the properties of the radium, like the same X-ray type properties. I think they were, because I read something. I'm not 100% certain, but I think I read something that talked about when the people, for example, when they had wounds, they used the radium as a sort of tube. They had it in like in a tube. So I think it might have been to actually show up like the beneath the skin, show up the wound, and then they would be able to treat it a little better or more accurately. I think so. I'm not 100% sure. But yeah. But I don't think it was a matter of ingesting radium and or anything like that.
Okay, thanks.
And radium is quite expensive, and that is why when the piece that we read said that the president gave her a gram of radium, that is something big, because the radium is actually quite expensive and quite rare. So it would have been like a huge gift. Right? Anybody else? Before I give you a task then. No. All right. Okay. Could you read for me? All right. I'm going to ask the three men. I'm going to ask Jason, Linton, and Samuel to read the PDF Science for All Women. All right, that's in your list. And then I'm going to ask the ladies to read Mind the Gender Gap. All right, so everybody have your instructions?
Okay.
All right. So I want you to read it. I want you to pick out I want you to be able to tell me what is the main point that is being made in the article, and just expand on it a little bit. All right, so that's what I need from you. So the ladies are reading Mind the Gender Gap, and the men are reading Science for All Women. Okay, that's it. So I'll give you about 10 minutes. Yeah, about that. All right, everybody, how are we doing on the article? Finished?
Yeah, I'm done.
Okay. All right. What about the others?
Yes, I'm done. Sorry.
Finished. All right. Let's take a 10 minutes break at this time. So yeah, let's take a 10 minutes break and just air out our heads, and then we'll come back for the discussion and we'll carry on. All right. So please take a little break. All right, everybody, have we had a good break? Are we back?
Yes. Thank you.
Okay, great. All right, so everybody's kind of reinvigorated, I hope. All right, so what we're going to do now, I just want to hear from you on the articles, and then we're going to go on to our local scientists. You're going to share with me persons that you research, and then I have a few I want to share with you. And then we're going to basically run out of time. But before we leave, I want us to talk a little bit about next week. Yeah, just one or two little housekeeping matters before we get off. All right. So, would the gentlemen, do you want to go first, or would you like the ladies to go ahead? I should ask that. Yes, gentlemen, do you want to do you wish to go?
Maybe you should ask the ladies if they want to go first.
All right. Ladies, would you like to go first? Wait, the ladies are not here?
We want to hear all those manly voices first.
Okay. All right, gentlemen, please go ahead.
Okay, yeah, Samuel Dominica.
All right, Samuel.
Yes, the article is about science for all, and really about women.
Yes.
From the article, I read that women are deferred from pursuing career in science at the highest level. Which is a waste of human talent, because they believe what men can do, women can do too. And also talk about the Women International Day. The question should be raised whether there's a progress which has been going for so long now, about how women have been stopped from pursuing their career in science at the highest level. And also there is talk about in US and in Europe that 0.5% of those who gain doctorate degree in science and engineering are female, but less than 1/5 of them become or became a full professor. And also about companies, when they have scientific advisory board, that they don't normally invite the women. And also some of the factors are blocking women from getting to the highest in their career. One, talk about the childcare, about gender bias, and also about politics. We mentioned of China and Portugal, what they have done to limit women from getting to the high of the rank. And also I noticed about they're talking about profile racing, is what they can do to make women get to the highest of their career in science. So Jason and Linton.
Yeah, for me, basically the main point of the article was just that they're creating the awareness that gender bias is still an issue in the scientific community, and then also to discuss some concrete things that can be done to overcome that.
Okay, good. Linton?
Yeah, and for me, it's like, well, again, just looking at the beginning where they have Women's Day for 8th of March, it's like long ago they would say that the females were not given privileges because they have to take care of the children. But I just want to add to say, like, now it's like Women's Day is a big thing around, especially in St. Lucia now.
Okay, so are you saying that there's the woman have eclipsed the men, so to speak, or you
Yeah.
that You think so?
Right. Yeah, because now that you find a lot of women want to do most of the jobs that the men are supposed to do.
Okay, so there are jobs that men are supposed to do. I don't understand.
So basically, from that, you could see that they had support from like the Christian Newsom Foundation, was actually giving like scholarships and putting things in place for females to get to the highest level of the society.
I think one of the things though, I mean, while we may see like more women, because like here on campus, like in our first year cohort, we have like 500 for chemistry. We have like 500 students, and perhaps 2/3 of them are female. But when you look at those, I mean, and even going up to final year, we still have more females. But as you said, some of the factors that when you think about how many females go on to grad school versus how many males go on to grad school, it's probably like a 50-50. And then those who go on to work in academia, you have more men going on. So the point, I mean, even though you may have more women having opportunity to go on and to study science, and they do, at some point in time, you kind of have a falling off. And I think that goes back to some, not necessarily bias in those particular cases, but in a sense, you could see that, you could argue that. But in terms of women wanting to raise families, right? I mean, then you're going to say, who's going to take care of the children? You know, and, you know, the lot just kind of falls on you that you're the one. So instead of pursuing your career to say a PhD, or if that is what you wanted, no, you kind of have to say, all right, probably I can only do a master's, and, you know, kind of let the man go ahead and do that. So there are some factors that kind of mitigate against women in a sense. And but I don't want to take the steam out of the ladies' article, so let me allow them to share. All right, so ladies, your turn.
What are we sharing, our article or the discussion?
You want to share on the discussion? You want to say something about?
No, I'm just asking. I'm not sure.
Right. So okay, so you can share your article now, and then we go back.
The article again, I think, mentioned a lot of the things, how biases also comes in with women, in terms of pay, in terms of promotion, discrimination. And we know that as women, I think we have had that conversation many times. I see Samuel, you probably would have remembered that, and Linton, I remember you too. It's a lot of factors. As you said, women are the ones who carry the children, and we make a lot of sacrifices that the men really don't take into consideration. It's not that we can't, because from stats we have seen that women generally gravitate towards education. They're the ones on campuses, they apply to university, and they bear the brunt of the burden, not a burden per se, but the weight. And we cater, we try to be very, when you have a family, I think we try to be very accommodating, because we still have some of the traditional roles in earth. And you know, you say you're supposed to give your husband, you're supposed to give the children, you're supposed to do so many things, you know. And yes, a man goes to work and and then some of them will provide financial support, but some of them, as we know, the Caribbean is filled with a lot of single parent homes. Yeah. So the mother is there to provide most times in need. How many homes are you aware that have both mother and father at home? You know, you have to work, you try and go to study, you have commitments, you have a lot of stuff. So generally, I'm not to be a bit biased, but I think if you weigh in all these factors, we do a very good balancing job at it. And we just, okay, we're the ones, we want to have a family, we are nurturing generally. We want to have, because sometimes I think if the males have to carry the child, it will be a different story. It'll be different, you know. And as a woman, I think you have certain needs. Some women feel, I might be going off, some women feel incomplete as a woman if you don't have a child. You really have to be strong. And people say, call you all kinds of names and you barren and all kinds of things. Society role, they tell you all. So if you, when you neglect your supposedly social role of becoming a mother and whatever, you know, you in for a bashing per se, and say, what's wrong with you? You don't want children, something is wrong with you. You married 5 years, you don't have any children, what, you know, all kinds of things. So I think all in all, women have a lot to carry, and you really have to make a lot of sacrifices when you want to go forward academically. And you know, you try to balance it. Being a mother is a great thing, but your own personal development also, it is hampered depending on how you look at it. So we just have to find suitable mates who current, who understands, who are not the backward thinking. A lot of men, I think they have that from their parents. Stay at home, take care of the children, and you know, just be in the background, you know. And if you find a suitable mate who understands, who's also at your level academically, he wants to see you, you know, climb and stuff, and he really cares about your well-being, I think things will go well. But back to the article, they did discuss women have to prove themselves at least 2.5 times more than the men. They had same scores, they had the same qualification, and yet they were considered for lower paying jobs, etc. You know, they would hire them because of they pay them less money, so it's better for the company. And in my previous class, somebody shared that when they go to an interview, they had to take off their wedding band because, you know, whenever the child gets sick, the mother is expected to stay at home. So that cut down on progress at the work, you know, these kind of things. They couldn't, and somebody told them, don't tell them you are married because they're saying you're a liability. You go off from, and if you're in the 30s, you a baby factory, so just need to go off and make babies and they'll be a liability. All these kind of things. So you really have, and men, you know, they're responsible because they have a child and whatever. Not that they take care of them, some of them, but you really have to do a lot of things as a woman in the world. And again, the men are the bosses, and they're very, very biased. So that's my 2 cents for now.
All right, thanks, Eva. All right, ladies, other ladies, please jump in.
Vanessa in Bermuda. I was going to say something about my husband's attitudes, but he's actually just walked into the house, so I'm going to keep quiet. Let's just say it's improving. No, actually, he's great. He is great, taking responsibility, looking after the kids, or I wouldn't be able to do this course. One of the things in the article that they highlighted was that you don't see a lot of women in the higher echelons of academia. So the women doing the degrees aren't seeing the role models, aren't seeing that they can actually aspire to these positions. Mm-hmm. So they become discouraged. Mm-hmm. And that was pretty much all I had to add to what Ava said.
Oh, okay. All right. Yes, other ladies, just chip in. Go
ahead. What particularly struck me was that we consider universities to be places of higher learning, you know, mm-hmm. where we expect a certain amount of enlightenment to be present.
Yes.
Yet still we're having male professors who would rather hire a male than a female, would rather mentor a male than a female, mm-hmm. who would pay a male more than they would a female with the same qualifications.
Yeah.
And so it just goes to show you that gender bias is not limited to any particular class or type of education, but it's straight across the board.
Yeah.
And as much as is being done to try and so-called enlighten people or make things more equal, it's still heavily male dominant in a lot of the fields, particularly the science fields. So yeah, that was my 2 bits.
Yeah, yeah. Ashley, you have anything you want to say on this? Ashley.
I mean, I don't really have much to say. I myself have experienced this firsthand. Ava added a good comment, I think, on how it's pretty much across many fields that we see this kind of discrimination. But regardless, I mean, how many years have women had the human right to vote and do other things? It hasn't even been 100 years, I don't think. So, has it been 100 years?
Yeah, I think it's from the 1800s, 18 something.
Okay.
Yeah.
So maybe just over a century.
Just over.
Okay. So, I mean, what can I say? We still have a long way to go until we can see more light at the situation. Yeah, that's about all I have to add.
Okay. For us to ponder though, when we hear the stories or when we read about the stories of the women in in the 19th century and early 20th century, and we look at what is happening today, do we think that we have come any distance? Have we covered any ground? Are we on our way?
Definitely. I mean, there are so many more amendments made to the law because of cases that have been presented. So, people are more being more conscious and cautious about the decisions that they make because of different ways of thinking that have been implemented into human rights and the laws and all this. So, yeah, we've made some progress, some headway.
Okay, so there is hope then.
Always, you have to keep it.
Yeah.
Alive.
Yeah. All right. Okay, so the discrimination continues. Just by way of just information, I'm not sure whose article it was in. It may be the men's article. Angela Merkel, who was a German chancellor, is a physicist, and Margaret Thatcher, who was Prime Minister of Britain at one point, she was a chemist. I mean, that's just put out there, you tell your students those kind of things. They might be a little bit stimulated by that. All right. So we're going to wrap the women. I have one story that left that I was going to share with you, but let me see how much time we have. Right. So I'm going to hold that story and actually send it to you in the PowerPoint. It's the story of an astrophysicist, right? Jocelyn Bell Burnell. So I'm going to, I'll send that to you and you can look at it at your leisure. And there are, I know, as I said, there are lots more. If you want like links and whatever just to see women in science, I can send you tons of stuff on that. All right, if you're interested in studying that. All right, so what I want us to do now, I want us to turn our attention to looking at some local scientists, some Caribbean people. All right, I basically have the Jamaican, a list of Jamaican scientists. So I'm going to allow you guys to share yours first, and then I'll wrap with mine, and then we will talk a little bit about next week. All right. So perhaps what I could do. No. All right. right, let me just ask you. All right, so who would like to share their scientists first? Yeah, that's it.
Okay, Samuel Dominica.
Oh, Samuel, please go ahead.
I was surprised to find out a Dominican scientist. I said, wow. But I hope he's still a Dominican. So I hope. So I'm going to share the screen with everybody.
All right, go ahead.
It's loading.
Okay.
Yes. So the name of the scientist is Harrison Prosper. So the question is, who is Harrison Prosper? Yes, that's the information I got about him.
Okay.
He was born June 8, 1956, Sucre in Dominica. Village less than 1,000 people, southwest of Dominica. That is more information about how Sucre is a bay, it's 5 SSC of Rosso. That's the direction where it is. Yes, this is education background. In 1977, he got a BSc in physics, University of Manchester, UK. In 1978, he got a diploma in advanced studies science physics, University of Manchester, UK. In 1980, he got a PhD in high energy physics. And that's where he did his finding in high energy physics about God particle. So this is the position he's holding now in let me go back. Yes, because he is a lecturer at Florida State University where he is currently. So he's a professor and also a researcher. So yes, so this is the experiment he was involved with about Higgs boson. Is about particles. It's a new finding about a new particle which is called the Higgs particle, which is also called the God particle. So he made an observation recently with his crew, and they found one Higgs particle. So yeah, this is the one at the middle there, and is other scientists and postgraduate diploma that did the experiment together to find the God particle. Yes, so I'm going to play you a short video about some of his explanations that I found on YouTube.
Oh.
Wow. The video not playing.
You want to send us a link?
Okay.
Oh. It's playing, but I can't hear him.
Wow.
Okay. Is that it? I don't think we're hearing it, Samuel.
Okay, so that is, should I go to the next video?
Yeah, if you wish. I will look it up. He's giving a TED talk, that one, right? The previous one.
Okay, let me go to the next video because
Okay.
that's all. Wow. I'm trying to get out of there. Okay, so this is a video that I explained the God particle, but it's not the one I explain it. So let me try to play that.
Oh. I'm not sure why, but I'm not getting any sound. The rest of you guys getting sound?
No, I cannot hear anything.
Okay.
No.
Okay.
Yeah, what if we get the links?
Okay. So.
But, all right. So what you can do, Samuel, can you send us? You could send us the links via email. We can.
Okay.
So we can look at them because I mean, what I'm excited about is that you actually found a Dominican friend.
Exactly. I was really happy about that myself.
Yeah, I'm really excited about it because I remember
I knew nothing about the God particle until I read about him.
Yeah, well, I've heard about it, but yeah, but
Okay.
I didn't know that somebody from the Caribbean was involved in that kind of research.
Okay.
So that is really enlightening, and you know, I think for a little child, or you know, even somebody in high school in your class, you come in and you talk to them about this guy who is doing, this Dominican guy who just came from some community around the corner that they came from, you know, and just talk about his story and the kinds of stuff that he's doing and where he has been able to reach. I think that could be really, really motivational, you know, for somebody, especially you begin to talk about their background, where they came from, you know, and you know. So that's really good. I'm pleased. I'm happy about that. Thank you. All right. Next one. Who would like to go next?
I'll go next.
Yes, Ava.
Just give me a second. I would also like to share my screen, so I'm not sure.
Okay. Yeah, go ahead. Okay. Yeah. I think there's a lot of noise. Oh, Vanessa, your mic is open.
Sorry.
Hi. Yes, Ava, we see your screen. Your PowerPoint is gone though. You took it.
I was trying to unmute the mic, that's all.
Oh, okay. All right. So we're hearing you.
Okay. Just give me a sec, sorry. Oh, what is somebody else? I have to put back. That's not the one I want, sorry. So I'll give you 2 minutes.
All right. Can somebody go ahead? Somebody else?
Okay, let me go before Eva get the person that I wanted to go.
Yes, Linton.
Okay, I must say I was impressed. I never knew that St. Lucia had a scientist.
Mm-hmm.
And I was asking teachers from my school, is there of any scientists from St. Lucia, and they said no. But it happened that my brother, who is a curriculum officer, I sent him a message and he told me to check NASA and I would get one. And he gave me a female.
Okay, cool.
Lucia, we have a female and her name is Andrea Andrew.
Andrea.
Yes, Andrea. Andrew.
Okay.
She was a former school teacher and she was appointed the position of scientist in January 2015.
Okay.
All right. Andrea, she taught at Cicero Secondary School, received a scholarship from the government of St. Lucia in 2004 to pursue a bachelor degree in science at the City University in New York. After completing her first degree, Andrea went on to read for master's degree in chemistry and a PhD in analytical chemistry from the University of Maryland. Andrea was awarded the Center of a Teaching Excellence Graduate Student Lilly Fellowship in 2011 by the University of Maryland, which develops and sustains cross-disciplinary learning of graduate studies as future faculty. Andrea has authored and co-authored several publications on various aspects of chemistry, which includes chromophoric dissolved organic matter, which is CDOM, in the equatorial Atlantic Ocean, optical properties and their relation to the chromophoric dissolved organic matter structure and source, and unfolding the optical properties of human substances, among others. Before leaving the United States, Andrea taught mathematics and integrated science for more than 8 years in St. Lucia. She was trained at the Sir Arthur Lewis Community College. That's where we do our course.
Okay.
Yeah, where she obtained a trained teacher's certificate.
Excellent. Excellent.
Okay, and what I have a picture of her. So can I just share my screen?
Well, Eva, you have to stop sharing the link.
Just show the picture.
This picture you saw of the lady, that was her. So I don't know if you saw the first lady that I had, but I'll move.
Okay, but if you have it, then you could go ahead, because that's why I want to present before you.
Oh, that's the reason why. Oh, that's so sad. Oh, listen, that is so sad.
Yeah. So you could add to mine.
That's okay.
Put your sound on.
You can go ahead, Linton. You can go ahead.
That's a nice picture. Okay. We don't have a close-up, but that's a nice picture. Like Ava's one, we could see her face better. That's good. Yeah. Okay. Thank you very much. That was good. Impressive.
Okay, welcome.
Yeah. All right, Ava, your time. I'm excited about these Caribbean scientists, seriously. I'm glad you guys went and looked up. Yeah.
Okay. Okay, can you see my screen now, everyone?
Yeah.
Okay, good. My Caribbean scientist is Deborah Pusod. I know the only person that I could have found was the same lady Linton had from the solution, so I decided to do another one because she was unique. She was the only person there.
Okay.
And this is a picture of what she looks like, Miss Deborah. She looks very jolly. Okay. She's a noticed virologist, and that's a person who studies viruses. She's well known. She was born in August 1960, and she's a Guyanese national of Indian descent, as I said before. At the age of 16, she, with her family, migrated to the US, and part of her education started after she had received her undergraduate. She went to New York School of Medicine, because I think they lived in Brooklyn. And then after she went there, she continued at the same institution where she got her master's degree. In between 1997 to 2004, she was the assistant professor at the very famous John Hopkins University. I think they do a lot of research and stuff there.
Yes.
I think if you graduate, you're destined for bright things. This is what they see. Just going to the university, I think it speaks for itself. She also was an associate professor of pediatrics in 2003 at the same university. And her main areas of focus were HIV, and it still is today, HIV/AIDS in children. But when she started these research, she more focused on the adults, and later on, I guess, her research moved to focus on little children. Her research was focused on, we have different strains of HIV. So her focus was on the HIV type 1. Okay, and for her patients, she would recommend what is known as the HAT, which is highly active antiretroviral therapy. We had a combination of drugs, and then they will give it to this patient and see how the body reacts to it, and then I guess they will make different dosages and stuff based on the viral load after a period of time. So she would do an observation, and then she would do a different, what we call concoction, to suit the individual.
Okay.
And they said early in her research, as I said before, she was mainly focused on adult patients, and she noticed that when she gave them this drug, they had lower level of viremia were detected in the blood. Okay, and she continued along with her research, focusing now on children. And research done by this great doctor, she noticed that the therapy that she gave to, she now wanted to give to these infants who are afflicted with HIV, actually suppressed their viral load, because she was not expecting that, because she know her research was mainly in the focus on adults, but she noticed that about the young children. So she placed these infants under this therapy, her drug concussion, whether she did her different doses, and again, she tested over a number of period of time, and she knows that these children under these therapy, when they went to test for them, there were no detectable levels of HIV in their blood. HIV, that's the strain, H1, type 1. And then she, along with the team, they had a mother who was HIV positive, and they had the baby given the drug. I think it's 3 days after the video said, after the child was born, they give them the drug. And for that, when she checked it over a number, I think the child was like 18 months, they stopped giving the child the drugs. And then they also knows that the child had no trace of that. So that was very, very a good, very groundbreaking research that she was involved in. And for that, she won the Elizabeth Glaser Scientist Award. They give that prize to her. So I'm just going to play a little video for you to see a little bit of her talking about it. Hope I don't get sound bells bug. Just a sec.
This is a very exciting time for pediatric HIV infection. Thanks to Dr. Gay, who identified this unique child in whom she started therapy very early, antiretroviral treatment for HIV within the first 2 days of life, and then ended up with this outcome in which the drugs were stopped, and it turns out that the virus did not rebound, which is what we usually see in patients who go off antiretroviral therapy. And so part of our studies is to, in an attempt to look at whether HIV can be cured, we've developed very sensitive laboratory assays to try to detect trace amounts of the virus. And so with this case, we received blood samples from Dr. Gay's office on this baby and the mother to begin to investigate why did this baby clear HIV infection after having been known to be infected in the first few days of life.
Well, I was very surprised when we first got the undetectable viral load after 5 months off of therapy. I really assumed that it was due to lab error. So I called her back in and we redid that viral load and also did some other testing. And I was exceptionally surprised when all of those tests came back negative.
Okay, then that's it.
Thanks, Eva.
Joe, just a while. I'm in terms of the video. Okay. And they also said that she was also nominated by Time Magazine as one of the world 100 most influential person. I mean, if you do that kind of research, she probably should be #1 in 2013. And also said last year she also had a second baby based on this therapy that she did. So very groundbreaking. I think in terms of inspiration, as you said before, a lot of young persons can look at this country and see that scientists are coming out. They have a brain like everybody else. They don't have to be the more developed country. They'll be inspired. They can relate to the scientists. You know where Guyana is. You know where Jamaica, St. Lucia, the different Caribbean countries. When you look at this, I think it's very, very inspiring, especially as we were talking about women scientists. They can see themselves in her and actually say, well, yes, I can do that also. You know, I don't think she had a very luxurious upbringing, but based on what things she would have studied hard. She would have known her goals, inspired by other persons, and help also. Parental guidance, etc., will play a very, very significant role in persons reaching where they are today. So I think it's very, very inspiring, and I'm happy that it's a woman. That's it. Thank you.
Thank you, Eva. Thanks.
You're welcome.
All right. Let's see who we have. Got Samuel, and we have Ava, we've got Minton. Okay, could we take one of the Bermuda? But I'm not sure what is Bermudas. That sounds funny. Okay. Vanessa or Tracy or Jason. Could you share, please?
Okay, I guess I can go first. I have a video, and can I just copy and paste the link into the chat?
Okay, yeah, and then we use it from there.
I think that'll work.
All right, we try.
1 second. So I guess maybe you could play it, Miss Stephenson, or and we could all look at your screen, I guess, or everybody can look at it individually. I'm not sure everybody can look at it individually if they want to, I guess.
Yeah. The quality is better if we do it individually. I'm not sure.
Yeah. And I guess there's a couple of things. There aren't a lot of Bermudian scientists, for one, we already mentioned that. So I really wanted to try and find somebody who was from Bermuda and had made some significant impacts. But also, he was very active in promoting social justice here in Bermuda and around the world. So a lot of the video talks about that, but it also talks about his some things he did in regards to ecological engineering, which I guess is like environmental engineering.
Okay.
And some things he did in that area.
Which one is he? Is he Roosevelt Brown or?
Yeah, Roosevelt Brown. How do you know about Roosevelt Brown?
All right. No. I'm not watching the video. Go ahead.
So you want me to share my screen?
No, I'm looking at the video. I don't even.
Oh, okay. Sorry, I didn't see that. Okay.
Do you have it up? You want to share yours?
Well, I haven't seen your screen if you're sharing it.
Oh, no, I'm not. Hold on.
Oh.
I wasn't. I'm not sure what you're seeing.
How come there's no sound? That's weird.
Yeah,
I can see the video, but I don't hear any sound.
Okay. Oh, that looks like a not so long. I think I hear something very low. Very low. Can't make out the words.
I said we can watch it on because we already I started.
Everybody can view it individually, I guess, is better because I can hear sound. It's only like 5 minutes, so.
Okay. All right, but this is the guy.
Yeah.
What area is he in?
I would say environmental engineering.
Okay, cool. Okay, he lives in Bermuda now, or he has migrated?
He actually passed away in 2007.
Uh-oh.
And some of his heritage, he was born in Bermuda, but his heritage is also West Indian as well as African.
Okay. All right, I'm checking out all of these things and I'm going to create a Caribbean set of stuff. All right, I look at it since I'm not hearing it now. We look at it afterwards. So we have a lot of homework to do, but it will be fun stuff. Well, this part. All right. So, anything else, Jason? Because I'm going to close the.
No, okay, that's it. Really, just the video.
Oh no, he did work on. Okay, so he did some solar. This is solar energy.
Yeah, we're starting to talk about the science part now.
Okay. This is in Africa. These kids here.
I think so. Yeah.
Yeah.
Yeah, like the first part is about his social justice movements and
Yeah,
stuff.
right.
The second part is more about the science and his achievements in that area.
Yeah, we saw some solar panels and like solar cookers and stuff like that. Like he did a lot of work with that, trapping solar energy.
I was just biased.
What?
What do you mean?
Talking to Miss. If it was in Africa, I'm saying by looking at the pictures, you knew that I was just biased skimming.
Oh yeah.
I just asked.
Yeah, but the video said Africa, I think, right? I don't know. I can't remember.
Okay then.
Ah, that's nice. Hey, I can't hear it now. All of that is his name?
Well, his name is like very long, so he either would go by Roosevelt Brown or Paulo Camargo Figo. But he's got, it's like a really long name.
Yeah, I thought it was somebody else, the first one. Okay, I just, all right, yeah, it's gone into something else. All right. Hold on, something is still running.
I think that's a different video, right? You should just be able to click it on the screen.
Yeah, I'm trying to stop it.
Oh, it's not working?
Okay, hold on.
Hi. Sorry, I got crashed. My system crashed.
Oh man, sorry, I didn't realize.
Uh-oh.
Yeah, sorry, Ashley from Bermuda back. My system had crashed, so I had to reboot quickly.
Oh, sorry, Ashley. Okay. All right. So Ashley, you have a scientist you want to share? Or you want?
Yes, I have a scientist.
All right.
His name is Luis L. Mowbray, Mowbray. He was born on the 19th of August, 1877 on the island of St. George's, Bermuda, and he died in the 5th of July, 1952. He was a Bermudian naturalist. He was the son of a school teacher, and his mother, Mary Ann Brown. The father immigrated from Louisiana to Bermuda in 1870. When he was well, in 1906, he observed the live Bermuda petrel, which is the cahao. It's the Bermudian national bird, which everybody thought was extinct, until this guy rediscovered it, and he gave quite some time to write a scientific description in 1916 together with John Nicholas. In 1907, he got married to Hilda, and they had a son, Luis Jr. And then I guess the research and everything died down for the cahao, but his son rediscovered the bird in 1951 with Mr. Robert Cushman Murphy and Mr. David Wingate. Luis was hired, now this isn't the son, but the father was hired by the Bermuda National History Society as a director for the first aquarium, which he ran until 1911. And then he went over to Boston Aquarium, which he ran for 3 years. Then he went and became the superintendent at the New York Aquarium. And then he hopped down to Miami, where he built and established the new aquarium down there. Then he rejoined the New York Aquarium in 1923 and finally returned to Bermuda in 1926. In 1928, he became the director of the Bermuda Aquarium Museum and Zoo, which he ran until 1944. He was actually the first to breed a specific kind of tortoises and penguins in captivity. So he must have had a special way with the animals. In 1943, he had a stroke and he was partially paralyzed. And then his son ended up taking over where he left off. That's it. Thank you.
All right, thanks, Ashley. And that's Louis Mowbray. Yeah. Okay.
Yeah.
Thanks. All right. Who knows? Sandra.
Can I share screen with you, please?
Go right ahead.
Okay, everybody seeing it now?
Yeah.
Okay, I looked at Dr. Lawrence Williams. And I hope everybody knows of it because he's done some amazing things. Am I not moving? Oh, there we go. He was born in St. Elizabeth, the second son of 5 children. He attended Calabar High School in Kingston, where he first fell in love with biology. And he went on to get his Bachelor of Science degree at the University of the West Indies in 1987 with a major in zoology and a minor in chemistry. After leaving UWI, he was employed by the Scientific Research Council, the SRC, to do research on natural product pesticides. And very quickly, about 2 months later, he started his graduate studies at the UWI. And he moved right into his PhD, which he got in 1991 for research in the biological activity of the Jamaican breadfruit. He went back to the SRC, where he worked for 3 years, did some lecturing at the UWI in the Department of Medical Sciences. And then in 2003, he was awarded the Alexander von Humboldt Scholarship to do postdoctoral studies on guinea hen weed at the don't ask me to pronounce that, Hohenheim University in Germany, where he was assisted in his research by 2 professors. Now, as a result of that research, they discovered the compound dibenzyl trisulfide, otherwise known as DST. And coming back to Jamaica, he did further work on it, and he developed, well, he first of all discovered that DST had some properties that actually worked on cancer cells. And he discovered that rather than using the pure DST, he developed a protein complex of it, which worked much better. And he has shown that it works on 12 kinds of cancers so far, including breast cancer, brain, lung, skin, bladder, and prostate cancer. So this was a huge breakthrough. And after 13 years of research, he acquired through the SRC the patent for this, along with his research partner, Dr. George Levy, who is a Jamaican-born medical doctor in the US. And the next stage now is to conduct clinical trials of the compound and develop a pharmaceutical agent for it. Wonder of wonders, in 2014, he was offered 11 billion Jamaican dollars. That's US 100 million for the patent that he holds. And he turned it down. And reason being, he thinks that the earning potential for this drug is far greater than the US $100 million. So in his words, I have a passion for research. I love it. It is my lifeline. If I stopped doing it, I would not know what I would do. I would die. So to allow you to hear Dr. Williams, I'm going to show you a YouTube video now. I hope it works. Yeah. Okay, okay.
You're not hearing him though, Sandra.
Not hearing?
No, you're not hearing him. But it's okay, I'm reading the stuff.
Still not hearing?
Yeah, I'm not hearing.
All right, I'm not sure why you're not hearing. I hear it, but
yeah, well, like you said, if you guys send me the links, because I'm going to look at all of them, and then so we can, if we're not hearing now, we can still go ahead and see them later on.
Right, sure. I'll give you the YouTube link.
Yeah.
After, all right. But just to close up then, let's see what he did. Okay, there you go. His contribution to science as a body of knowledge, his numerous journal publications, his patents, and he's a consultant to 5 researchers now at the SRC. So a way of investigating, he has done very careful investigative work into the guinea head weed, which has allowed him to develop this protein complex. And as a way of thinking, his background from St. Elizabeth, where he grew up with the guinea hen weed, his curiosity led him to do studies on the effects, clinical studies on the effects of the weed. So how could we inspire our students? Well, one, through his dedication, the amount of time and effort he put into his research. He's inspirational as a Jamaican and Caribbean scientist, and the potential for the cancer curing pharmaceutical products which may be produced and manufactured here in the Caribbean, and the general worldwide impact of his work will truly be enormous if he actually produces the product. And that's my contribution.
Thank you, Sandra. Thank you. All right. This is good. Yeah. Yes, Eva.
Sandra, did you have a photo of the weed, the guinea hen weed?
Yes, it was in the YouTube, but let me see if I can find a picture of it.
It looks like a herb that we normally use for seasoning. I'm not sure. Meat and stuff.
Oh, it was two stuff. One of them, I think, is plain. There were two plants that we saw.
Yes, I was thinking that one. Okay.
Yeah, I think it's a darker one though. The second one, the darker leaf, it's kind of shiny.
Yeah, in St. Elizabeth, we tend to people tend to think that guinea hen weed is a cure-all for everything that you have. You know, you go and cut a leaf and boil it and drink it. You know?
Okay.
That's the big broadleaves, the second photo?
Yeah, I think it's the second one, yeah. The time one is in the time one, the first one. I think the one that looks like a kind of thyme, it's kind of soft. I don't know. You find it, Sandra? Ah, there it is. Oh, that's bush. That's all I'm calling it. Say that's bush. I didn't even know that was useful. Okay. All right. Thanks. Okay. Tracy. Tracy. Tracy, are you there?
I'm here, trying to multitask, not doing a very good job. I sent you some stuff, but I don't know if you got it.
Okay, so Neil's website?
Yeah.
Okay.
I would like people to see the pictures while I was talking. It's of the scientists that I'm going to talk about.
All right. So, okay, so it's a Word document.
Or I could send it to everybody. That's what I was doing, I think if I try and hit the share button, I won't see you until Tuesday.
Okay. All right, that's all done. And let me see if I can share it for you.
That'd be nice. I could finish the class off.
Yeah. All right. Can you guys see that?
Yes.
Okay. All right. So that's go ahead, Tracy.
Yeah.
Okay. My scientist is Neil Burney. He was actually born in Liverpool, but became a naturalized Bermudian. He got his education in Bristol, University of Bristol. He came to Bermuda as a government vet in the 80s. In the 90s, he became a managing partner of a veterinary practice. In 2005, he became the co-founder and lead researcher for the Bermuda Shark Project. The picture that you see there is a tiger shark, and it's a photo from his shark project. I don't know if there's any of you, but I would not be swimming with that shark.
Neither would I.
I chose him because he was the complete opposite of Henry Cavendish, who I did on my last presentation, well, earlier today.
Okay.
Neil had a very gregarious nature and an extrovert personality. He was a showman and a colorful character. Oh, I actually forgot his dates. He was born in 1954 and he died November 2014.
Yes.
He was, as I said, a showman and a colorful character. It wouldn't be that abnormal to see him like playing his saxophone barefoot in the streets, or playing his harmonica while in the visiting hall of his veterinary practice. He was just definitely not shy, as Henry Cavendish was. Although he's done some very serious research, he loves to share his research through song and documentaries. If you could scroll down there, there's one song. He's not a very good singer, but you get the point of how he's trying to get people to be interested in the sharks. If you scroll down a little bit further, you should see one that says "Time to Save the Shark." Go down. Yep, that first one. Up. The first link. It's only like a minute and a half, I believe. If we could just share that, yes. You should just be hold control and click.
Yeah, but it's not working. All right.
It's probably not worth continuing. I'll send a link to everyone because it's actually got some really pretty pictures of him swimming with the sharks. So it's lost it with the translation.
Okay. All right. Could you spell his last name for me?
Pardon?
Could you spell his last name for me?
Bernie. I've just sent the email to the rest of the students. I don't know if they want to watch it. Like I say, it isn't long, and it kind of makes a point of my talk. So I don't know if people have 2 seconds to watch it. Have you received my email?
I got it.
Okay.
Yeah, I got it.
Would you mind watching it? Because it's like, and just, if it doesn't have the picture, it's no point. It loses its value.
I'm not going to put it up because the last time I tried to do Zoom and a YouTube, it crashed my system. So I'm not going to.
Okay. I could hear it on my phone. So. I saw it. Time to he wrote that song about time to save the sharks.
Yeah, he wrote the song, but it's actually, I mean, he's not a very good singer, but the actual video is actually really good. Like, just so that people could see what he was doing. Like, it's the same thing. I wouldn't be doing any of that stuff.
Yeah.
Are you getting the picture? My classmates?
Yes, I got it.
Not yet on the screen.
Can you let me know when you're finished?
I've finished. His singing's a lot better than mine.
I'll leave that alone.
My kids go to sleep in self-defense.
Have the rest of us been able to see it? Hello?
Hello? Yes?
Yeah, I'm just checking because Tracy is actually waiting on us.
Oh, but you can go ahead. I'll look at it later. You can go ahead.
Oh, okay. All right, Tracy. Yeah, you can go ahead and finish up.
Okay, so as he, like I said, he did songs, he did documentaries. If you're interested, on that email I sent you, you'll see the Tiger Shark Highway. That gives you more of the details of his actual proper research. But also in that email, you'll see I Want to Have a TV Show. That's it's another song he sang and wrote it himself. But his personality and presence in front of a camera, because of it, he was actually asked to be the star in a breakthrough television series called Ocean Vet, which is a 12-part television series which explores Bermuda's very marine life. The series was not complete when Neil had his untimely death in a marine accident. So it's not going to start until 2015. And it's actually, instead of him narrating it, it's going to be Michael Douglas, who is also is a Bermudian. But I think it's kind of interesting if you look at, you see where I said Ocean Vet trailer here on that email?
Yeah.
If you open that, it just gives you some idea of the types of research he was doing. So it's a very short one, so if you could just follow that, have a look at that, and let me know when you're done. Is everyone getting it?
Hold on. Hold on. Are you guys seeing my screen?
I didn't get any email, no.
Oh, sorry, Ava.
That's okay.
I just added it to something that we were sent earlier today.
Okay.
I have you on the list, but I guess you didn't get it.
No,
I just sent it.
Correct. I didn't get anything.
Sorry about that.
That's okay.
What is your email address?
avacolimo@yahoo.com. AVACOLLYMORE.
Was everyone else able to see the trailer?
I'm looking at it.
Okay, sorry.
Yes, finished.
Oh, that's for the movie. Okay. Yeah, I've got that. Okay, Tracy, we have it. I've gone through.
Okay, has everyone seen it and I can move on?
Yes, I haven't.
Yes, Tracy, you can go ahead.
Okay, so, I mean, you can see he had a different way of expressing his research, but if you look at the TEDx, you'll see that he did an awful lot of research. And he definitely has shared it with Bermudians, so quite opposite of Cavendish, who wrote all his research but never shared it for some of it for 100 years. And anyway, he was not always just showmanship. Like I said, in 2005, together with another Bermudian, Choya Ming, they founded the Bermuda Shark Project, which it tags sharks, tiger sharks around the Bermuda platform. And that's quite important because as a top predator in our marine ecosystem, large sharks are clear indicators of the ecosystem's health. And unfortunately, they're being overfished, so it's important to learn more about them so that we can protect them. Like I said, the TEDx talk had a lot in it. I just thought it was worth sharing the different styles of scientists, and that not all scientists live in a lab.
Yeah. Well, no, we have the files, so we can go through. We have a lot of stuff that we actually have to go through. But you guys have the weekend. Hopefully on the weekend you take some time out to do this as well. So we look at them again. I've looked at them already, but I will certainly look at them again. And I hope everybody else will too. Hi Tracy, is that it? Are you finished?
Yep, I'm finished.
All right. Okay, guys. Well, I've had a good time. It's been you know, a little long, but I've had a good time. I've learned so much. I've learned about about scientists from Dominica and St. Lucia and from Guyana and several from Bermuda. Excellent. And I have several Jamaican scientists who I actually wanted to share with you. But what I will do, because our time has expired actually, so what I will do is I will send you my PowerPoint on Jamaican scientists so you can also be exposed to some others. So thank you very much for staying for the long haul and for being good sports and participating. All right, and just quickly, as I said, we have a few other little things that we still have to do. We're going to finish up the second assignment on Tuesday. So on Monday you will send me the first part. On Tuesday we will have the test. But on Tuesday we also will have a reading. Right? We have 2 graded readings. You did one already. You have the second one. All right. So I think I have already sent you the reading. No. Oh, I posted the reading on OURVLE. All right, so could you make a note of that for me? So it's already up. It's in a folder, and when you go in the folder, there's a Word document in it that tells you who is assigned to what. All right, so you'll see that. If you have any issues at all, just send me a little email, and I will get back to you on it. I think about 2 of the articles are quite long. Under 30 pages, but quite long. And so what I have done is to assign them to like 2 persons. The way you can do this is you could share, one person could share half of it and the other person share the other half. What I'm suggesting that you use for the presentation or to share what you have read with us, that you use about 5 PowerPoint slides, not more than 5. All right, so see if you can condense the research, what you have read into 5 slides, and I've given you some guidelines as to what it is that I want you to focus on. So
this is for part B that we have to have 5 slides for?
I'm sorry, go again.
Sorry, you're saying this is for part B of the assignment coming up on Tuesday?
No.
We have to have 5 slides for?
No, there are no slides for part B of the assignment. Part B is something you're going to write. Remember, we're going to on Tuesday next week. Remember, you're going to be in your centers, right?
Yes.
Right. So somebody at the center will actually give you a paper, and you will write, and then they will send back those hard copies to me. So this doesn't have to do with that. But I'm saying, because remember, we're also having class on Tuesday. The the test is an hour and 15, right? So for the rest of, as another part of our class, I'm giving you a reading to do. So this is a reading. So I'm saying, you know, so I've given you a reading to do and you have come and shared. And I'm saying probably an easy way for everybody, I'm asking everybody to just prepare 5 slides with basically what you want to share from the reading. And I have already in the document that I've sent you, I have asked, there are some things that I ask you to focus on as you read. So those are the things that I would expect you to emphasize.
I see, thank you.
On the slide. All right. I want to make sure that we're all clear and are on the same page. So what I want to do.
The slide is for Tuesday. The 5 slides for Tuesday.
Right.
Yes.
Right. All right. So we're doing a couple of things on Tuesday. That's the point. We're doing a couple of different. All right. So first, one. Remember, Tuesday we are at our sites. That's 1. 2. So at some point in time, we're going to do the second part of assignment 2, which is the writing part. And also, I'm asking you to prepare this reading. I know it's a little bit of pressure, but we have little choice. And next week is our last week. So I also have to give you your final assignment.
You can't have an extension on part B, like till
no,
Wednesday?
Wednesday? We don't meet on Wednesday.
I know, but last time we had to do on Friday, we didn't meet. I'm talking about the writing.
Oh, you mean the written part?
That we have for Monday, just because that's a lot to do this presentation, I think, and do this plus other stuff we have from other classes.
I could do it, you know. I could do it. The thing is, think about the pressure that you're going to bring on yourself, because then I'm going to give you assignment 3 as well. So do you want to do that? When I give you assignment 3, I can give you 1 week, which would be basically the week, the break. So after I give you assignment 3, you could go up to like the 17th. You could have up to the 17th to finish it.
Yes, thank you.
That would be nice, yeah. Right. Then other question, sorry. Jason, are you done? Sorry.
No, I actually had another question. I was wondering about, are the readings in graded readings unit 4 on Orville?
Right.
And so where it says reading assignments, that's the...
Right, so you're in the folder and you see that Word document, that reading assignment.
Okay, just wanted to confirm that.
Right, so if you open it, you'll see all your names and what's there.
Okay, thanks, I'm done.
Okay. And the articles are also in the same folder.
Yes, one question.
Yes, Ava.
Because of my area, I'm not sure. In science, I don't agriculture science. We don't have planning and designing per se.
Okay, so Ava, just read it out of one of the.
I'm a bit confused as to what to do. I'm lost. Sorry.
Okay, but it's just reading about planning and designing, you know. So you can't read out of your syllabus, right?
No.
Right. So you need to take one of the, whether it's a biochem or a physics syllabus.
Yeah, borrow bio syllabus today. Yes.
Okay, and I'm supposed to send you guys. I had written that down. I said I would send the syllabus in.
Yes, please. Thank you.
Yeah. I'm writing it down again.
And when you go to planning and designing, okay? You just have a step 1 and step 2.
No. It's a reading.
You don't have it in the bio. It's not unless it's outdated, but I don't see it. But
okay.
Online, I can just get planning and designing.
I will check. Okay.
No, I can do it myself. I'm just asking.
Yeah. No, because I mean, what I could do is just send everybody a bio syllabus if you want. I have the biochem and the physics, so I can send.
But just that part, yeah.
No, I have to send the whole syllabus. It's a PDF.
Okay. Yeah, it'll be easy. Yes. Okay, and do that. Okay. That'll be nice.
Okay.
under pressure, and everybody wants some of our blood.
I know.
What about the first assignment? Is it okay?
I haven't actually marked it as yet. I'm going to see if I can spend some time looking at it this weekend. But I too am under some pressure. So yeah. But I want to try to do that. And Jason, I mean, if you guys are all right, if everybody's okay with it, I mean, if you feel that you are stretched too much for the Monday, I don't have a problem with it for Wednesday. I just want to try to balance you guys in terms of the other things.
Yeah, I'd like to get everyone else's opinion on that. I don't know how everyone else feels.
Sorry, what was it, Jason?
About getting an extension on this assignment that's due on Monday, like get it extended to maybe Wednesday or even Tuesday. I don't know, but I just feel like we have a lot going on.
Yeah, Wednesday is fine by me because we have the assignment on Monday, the presentation on Monday, the other classes. So and lesson planning, yeah. So that'll be nice because it's one after everyone is a day, the next day. So Wednesday will be fine if that's okay. I mean, you have to do what you have to do, but if that's okay, I'm good for it.
No, I'm all right. I'm okay with that. So I'm just checking with everybody else. I mean, if you guys are good, that's what we do.
Everybody say yes. I have it. Yes.
Yes.
Amen.
Yeah, everybody's pretty quiet. I don't know what's going on.
Yeah. Some of the
It seems like, oh my God, everybody have it. We just begging, like,
yes. Some Dominica.
Yes, Samuel.
Yeah, I think it's okay because I have so much to deal with. Now it's like, oh God. So I think that Wednesday is okay, but I have so much to do. But
yeah,
I know we'll survive it. So yeah, Wednesday is okay.
You will survive it. We have just a short time to go, and you guys, you will make it. I guess you take assurance in the fact that others have gone before you and made it. You'll make it.
Yes, there's hope in that.
Yes. All right, I'm going to release you. I mean, we have gone longer because I was going to give you back a break time, but we have gone a little over time, but that's all right. All right, so have a good weekend, everyone.
Excuse me, please.
Have a great weekend.
Yes.
So excuse me.
If I can just put in. Oh, okay, go ahead, Samuel.
Yes, the center are aware that we're coming on Tuesday. The open campus are aware we're coming on Tuesday.
There should be our office here. Should talk with them, but okay. I will remind them again.
And the paper we'll be using will be given to us by them, or we have to come with our own.
They should give you paper.
Okay, thank you.
But it doesn't hurt to bring some just in case. But they should give you university paper. Yes.
Please remember to send us the email, Professor.
The syllabus, right?
Yes, please.
Yes, I remember. Okay, thank you.
If you forget, you'll just forget too. Assignment.
No, if I forget, if you don't see by this evening, what you will do is you shoot me an email and say, I have forgotten, please remember. That's what you do.
Yeah, that's right. Have a good weekend. Bye-bye.
You too. Thank you very much. Take care, everyone.
Take care, everyone.
Vanessa and I just
Bye.
shared PowerPoint presentations on the science if anybody else wants to email.
Oh yeah, we could share all those presentations. So you guys could share across the PowerPoints that you did and stuff. Just send them to everybody. So that's good information to have. Thank you. Bye-bye. Take care.
Yeah, bye.
Bye-bye.
Bye.
Bye.